We've been doing that since 1996, so we've been around quite a while. I'm not really sure what happened there.
You broke it, Seth.
Oh.
Did I break it?
Anyway, today we'll get some good information on the Hitachi screws and how to service them, troubleshoot them, that kind of stuff. I sent out that brochure, another kind of plug. We are the national distributor for Hitachi, still are. But here last 3 or 4 years now, we started bringing on some other compressors. So the sheng compressors, Train, York, Carrier, about any other compressor you guys need, let us know. We can get you some good pricing on those compressors.
We're talking like the 06Ns?
Yep.
For sure.
Yep. Even, we aren't remanufacturing recips, but we got a lot of connections to get some good deals on those recips. If you want us to get you a price on that, I know we're in Missouri, so, shipping to get it out here, sometimes that kills the deal. It's like, I can get you good pricing, but once I put shipping on it, I can get it locally cheaper, which that's fine. I'm not here really to pull you away from your current vendor, but if you want, just some competitive pricing, or I'm having trouble, the lead time's always a long time, give me a shout, maybe we can do better for you.
What's the 06N? Is that the 38 HMC?
Yeah.
Oh, jeez. You guys carry those? Oh, cool.
Yeah, just let us know, I can get some good pricing on that. So we're trying to expand our product offering, like I said, for 20 years, all we did was Hitachi, that's it. We did all Hitachis, and there are basically 3 brands, or 3 models, the 40, 50, 60 horsepower. So it's a pretty small selection, but if you need a Hitachi, basically, you pretty much came to us. We offer new and remanufactured. The new come from Tokyo, Japan, from the factory. Remanufacturing happens at our facility in Missouri. It's all to factory specs. It's completely gone through. Screws, motors rewound, bearings, gaskets, everything's replaced. So it is a true remanufactured compressor you're getting. I kind of stand behind our remanufactured almost more than a new, because we do a live run test on them at our facility. We're not a little different than most rebuilders in the field. Most of them do a compression test. You run 5-10 seconds, boom, you're done. That's your test. We run for about an hour, hour and a half. Thing runs, load, mid-load, make sure everything sounds good, looks good, kilowatts are good, amperage all looks good before we qualify it to go out. So going through all that battery of tests, I feel very confident our rebuilds are, you're going to get a good one when you get it. Like we talked a little earlier today with a couple of guys here, some of your customers, they don't want rebuild, all they want's new. So we have new as well. If that's what they want. Either way you want to do, I'm sure we can accommodate whatever you guys need. Did everybody get a chance to download the manual or get a hard copy? That's what we're going to be going through today, is this manual, just so you have a quick reference to be able to see what we're going through. And it's a very informal class today, so at any time, I'm talking or we go over something, you got a question, stop me. We can stop at any time, and if you got any questions or didn't quite get it, we can go over it again. That's no problem at all. So initially, this is the table of contents through the manual. It's a pretty detailed manual. Every compressor comes with a service operational manual, but you get some pretty basic information, but this is a little more detailed and a little more in depth, so it should help you out, I think, in the field a little better. We'll kind of tab through that. Section 1 is just general information, introducing our company, what we do. Again, we're in Marshfield, Missouri. Offering new and remanufactured a complete line of replacement parts. They're all factory parts. There aren't aftermarket parts made somewhere else. These are all coming directly from the factory, so you always get factory replacement parts. And we do offer on-site rebuilds as well. Currently just on the Hitachi. I'm sure we're going to migrate into other makes. We may be able to offer that on. That way, if you got a customer that's got a unit that's very hard to get to, I've got several, we got customers all over the U.S. and again, in these big cities, sometimes you get a high-rise building that you got a compressor on, and you got to block off a city block or something just to get a crane down there to get this thing on the roof. That's a very expensive process. We can send a couple guys to do the complete rebuild on site. They bring everything to do a rebuild, even a main casing and everything, so they could actually assemble a compressor on site so that they're not going to leave without something running. So they can tear into it. But for some reason they got in there and the casing was all galled and so bad that, I can't put this thing back together. It's not right to do. We normally junk that. Well, then we have a casing out in the trailer in the truck that we could actually haul up to the roof and put one together for you. So just keep in your back pocket, if you guys ever need something like that, let us know. Again, right now we're just doing the Hitachi compressors on the on-sites, but hopefully get everybody more comfortable with some of these other ones. We might be able to do those as well. And the first sheet, there's two different series of Hitachi compressors. Originally there's the 2 series, which would be a model number of 4002 SC-H, a 5002 SC-H, and a 6002, which is a 40, 50, 60 horsepower. And about, this is a spec sheet on the 2 series. Shows cooling capacity, motor input, overall dimensions, shipping weights, displacement. And these can be applied to 50 or 60 hertz, the motors. In some older units, you guys have seen some bone units, they put the 40, 50 hertz voltage on the nameplate. Hitachi just puts the 60 hertz when they come here, but that motor can be applied to 50 hertz as well. So if you wind up getting a customer that is for an export or something like that, we can still accommodate that with that same compressor. Now it's going to show up with 60 hertz showing on there, but it can be applied to 50. So hey, I need 380 volt 50 hertz, the 460 volt 60 hertz will still work just fine for that application. Piping sizes, that kind of thing, that's just kind of good to have on hand. And on brochure, then like I said, in about 2000, 2001, they upgraded the 2 series to what they call a 5 series. And basically, all it is your 4002 SC-H is now 4005 SC-Z. Same thing with the 5 and 6. It just says 505 702. It's still a drop-in replacement. Footprint's the same. Piping's is exactly the same. The only real difference as far as installation is there's 2 unload solenoids that sit right next to each other. They just switch places. One is there's a rapid unload solenoid, and one's a normal unload. Rapid unload means when you start the compressor, that energizes for 30 to 60 seconds to rapidly unload that compressor to full unload. It can go from full load to full unload in about 5-10 seconds. And the normal unload is for normal operational unloads. It goes through a little capillary tube for the oil. It's like a hydraulic function. And that slowly unloads that compressor during normal operation. Those coils are, like I said, right next to each other. You just take the screw off the top of the coils and swatch the coils. You don't have to remove the valve itself, just change the coils. So it's real simple. And anytime you get a 5 series compressor, you get a manual that shows you that difference and tells you what that is, and there's that information in these books as well. There's also a 100 horsepower compressor on this slide. We sold those for a few years, and Hitachi discontinued that, so there wasn't enough interest. So you may come across that. That's why I left that in here, just in case you ever come across a Hitachi 100 horsepower compressor. You'll have data on that compressor as well.
Quick question?
Yeah.
On the SC-Z, we put a couple in, and that's just the more efficient ones. You can get the 60 horse SC, or you still get the standard one?
When they went from a 6002 SC-H to a 6005 SC-Z, the efficiency is about, I think it's 2 to 3% more efficient. The oil separator is a little bit smaller. It's supposed to be a little bit quieter. They revamped the terminal plate on it, how it's assembled, and so there's a lot less chance for leaks. The 2 series did, if you had high pressure over years, it could cause a little bit of leak around the terminal plate. And it's got an internal grommet in it that you assemble it, torque it, bake it, torque it to compress and seal that stud. And the 5 series threads down through the plate. That's been a much more efficient design. And with the 2 series, those were just approved for R22. The 5 series, you can use them on R22, 134A, or 407C, any one of those 3 applications. And I have pushed some of my clients of, hey, if you're looking to go to a different Freon, you might go ahead and get a 5 series compressor. If you don't want to do the retrofit now, you can stay on R22. That way you can kind of stage that retrofit. I can do the compressors now. Maybe next year we'll do something else and get it converted over to 407. Then you can still use that same compressor. Just evacuate the oil out and get it cleaned out and charge it back up. You're ready to go. So it's pretty simple. Throughout the world, the United States, there's a tremendous amount of demand for high performance air conditioning. Hitachi was one of the main developers of the screw compressor technology back in the 60s. And then in 1973, they came out with an open drive, and then in '79, they led the way in introducing the first semi-hermetic screw compressors. 40, 50, 60 horsepower. And actually, there was one earlier family of compressors called a 1 series. So that 5002 was a 5001 originally. It had external solenoids on the compressor. It was just made a little bit different. And so they upgraded that a little bit and went to the 2 series. I doubt if you've seen those 1 series. If you do, those things will be 35, 40 years old by now. So they've been around a long time. Hitachi now has not only improved the design on these workhorses, they also have a strong demand for large capacity units. Then that's why they added the 100 horsepower line back. But again, like Europe and Asia is their major market. They still make those compressors for that market, but the U.S. they just didn't. We sold maybe, I don't know, 50, 60 of them, but they were looking for hundreds of these things to go out, and the OEMs weren't biting. Hitachi isn't the most cost-effective, no, I shouldn't say cost-effective, it isn't the cheapest compressor on the market, put it that way. It is one of the highest quality compressors, I think, as far as the screw compressors go in their tonnage range, but it's not the cheapest. So when you talk to the OEMs and they're putting together a unit, bottom dollar does drive the market. That's why, they went with some of these OEMs use 3 or 4 or 5 different other kinds, depending on what's the cheapest at that time. Bitzers, Copelands, whatever. If they get them really good and cheap, that's the way they went. If they can get the capacity out of it, get it out of their warranty period, that's the way they went. Again, we still do sell some to some custom OEM units. Most of it is for those custom units where the vibration and the noise has to be very quiet. If you get in downtown LA with an apartment building or something where you can't be loud, it can't be, they just can't have it, that's when they may pull the trigger and get Hitachis on there, because they are very, very quiet and very low vibration. So when you put one of these compressors in, you fire it up, and that thing seems like it's got a bad vibration to it, or this thing's pretty loud, something's not right. I mean, it should be very, very quiet. You should be able to actually sit there and stand right next to this thing and talk and have a conversation right next to it. And if you can't, that's not right. And I know that's not the way it is for a lot of compressors, some trains. And I'm not here to badmouth anybody, compressors, because it just is what it is. Some of them you can't stand next to them and talk. And I don't know how it's hard to troubleshoot one or, service one, figure out what's going wrong if you can't hardly stand next to it because it's so loud. When it starts getting loud, what does that mean? I hear it from downstairs before I get to the unit, But anyway, they should be very, very quiet. If they're not, then you need to dig into it, find out what's going on. But you want to be careful too whenever you install one. I've had more than one time the guys would put one in and said that this thing's, I got the weird sound. This thing's got a loud noise at startup or something like that. I went to one recently in Tulsa where he said this thing just hammers at startup and then it quietens right down. He's like, I can't figure it out, but it's got him scared to death. He shut it off, didn't want to run it. So he said, when you get time, can you come by here and check it out? And I said, yeah, I'll do that. So I went down there and went up on the roof and said, okay, let's start it up. And it did. You start it up and it's and then just kind of smoothed right out. It's like, well, what the heck's that? Started looking around on it. And he said, yeah, how they were putting it all in. There's a little box on the side where the motor thermistors are, motor sensors are. A little 4x4 box, got 2 screws, holds it on. So the screws were sticking about a 1/4 inch out where it wasn't tight on there. That's all it was. The box was loose. Tighten those down, start it up 4 or 5 times, it's just smooth every time. It can be something very simple as that, it's just something loose. It can cause, something abnormal. So sometimes the most simplest thing can be, you can sit here knocking your head together. It's got to be something more complicated than that, but a lot of times it's not. So noise and vibration should be very, very quiet. When you install these compressors, there's also, it's always good if you have a set of springs or pads on the feet. Never mount these things down hard to a hard surface, because you will get a harmonic vibration out of it. You'll do that on any compressor. You want to either have them floating on some pads, so tighten it down, then back it off a 1/2 turn or so it's not just squished down on it. So it's sitting there with something a little bit to ride on. That'll make it a lot quieter. Some of them have springs in them, some of them have pads. If they got pads, a lot of times it's good to get new ones whenever you get the compressor, because you lift it up, 1,000-pound compressor is going to just tear apart, come off with it. If they're springs, it should be just fine to reuse those. But just something to keep in mind. The features on the screw compressors, they got a patented double wall casing structure to keep it very, very quiet. Triple ball ball bearings designed for heavy axle loads and long life reliability. The combination of the inner compressor construction oil separator reduces compressor size and simplifies the refrigeration system. Hitachi does have an built-on internal oil separator. It's this 2.5, 3 foot long vessel right here. Some compressors like Train and some other compressors have an external separator that are on the compressor. This has it built right onto it. It's got a demister right here in the mesh, metal mesh right here that separates that oil from the Freon as it flows through. So that kind of less components in the system keeps it that much tighter and that much close. Easier installation. Highly reliable 2-pole large capacity motor, provides low noise, low vibration, and high speed operation. 3750, I believe, is the rotation on the motor. It is a 6-pole motor, 2-pole motor with 6 terminals, so you can go this on a direct start or a Y delta start. So if you got 6 leads coming down that compressor, you got a Y delta hookup, or if you got just 3 power leads coming down with cross light bars on it, that means you got a direct start on that compressor. We got some drawings we'll get to here as we go through this to show you how to connect all that. The compressor does come in infinite or step capacity. 99.9% of the compressors in the U.S. are infinite capacity. That just means when you energize that load solenoid, it's going to start loading it up, and it's going to load until you de-energize it. Step capacity, you got to energize a certain amount, sequence of solenoids that goes to 25 or 50 or 75%. It just makes that jump. There's nothing in between. But the infinite capacity will just linear load that thing up until you de-energize the load. It should stop right there and hold. If it loads on it by itself or unloads by itself, that tells you something's wrong. So it should hold wherever you de-energize those solenoids at. And then we'll talk before about the 5 series for R22, 407C, and R34A. The oil we use now in the compressors is SW220HT. It's a POE synthetic oil. That's what's in the 5 series compressors. So even if you get a 2 series compressor today, we still offer those, but only in remanufactured because you can't get them in new anymore. But we use the SW220HT oil in all of our compressors. Here's another data sheet on the 5 series. Basically, again, this is just some spec information. If you need no dimensions, length, that kind of thing on them, pipe sizing. Cooling capacity, overall dimensions, weight, displacement, piping. Safety precautions, again, you know, we got to stress this immensely, is always be careful when you're working on one of these things. Be sure you abide by all codes and safeties. I got to say that start up front. Pressure may be hot during operation. You're going to be cooling the motor end. The discharge end, that oil separator is going to be very hot to the touch even. The oil is always exposed to discharge pressure. That oil is going to be hot. So be very careful if this thing is running and you're wanting to open this thing up. You don't just shut it down and start cracking it open. Be very, very careful with the temperature and the oil and pressure inside of it. There's no valve plates in the compressor, so when this thing shuts off, you're going to hear it backspin a little bit. That's not running backwards, it's backspin. So big difference between the two. When you fire one up, you always want to be sure that the thing runs clockwise rotation. There's a one-way check valve will be on the discharge line on the discharge end. So it runs, it shuts off, you don't get any migration back on refrigerant. But if you start this thing up under full load, it's trying to run at full RPM backwards, it's sucking against that discharge and driving these screws back into the discharge casing. So just a matter of seconds, you can actually crash a compressor, so you gotta be very, very careful of that. But I always recommend, you can put a rotation meter on it and all that to check your phase rotation. But if you put a set of gauges on the compressor, within 1 second. I mean, as soon as you start that thing, suction's gonna drop, discharge goes up. Just keep your, you know, if you are where you can have a guy at the kill switch, another guy watching those, I mean, just immediately, if you see the suction go up, it's going the wrong way. Just, I mean, you'll know immediately. You might be able to save that $10,000-$15,000 compressor from getting killed.
Hey, Don, are all the compressors wired?
Are they what?
Are they all wired
Wired?
the same? So if I pull one out and I mark the wires on the feed,
Yes.
it's coming in, my new one's gonna be the same, right?
Should
So
be.
the only way it should screw up is if I swap the wire.
Yep.
Okay.
Now, I say
I
that.
know.
I say that.
Right.
I have had, I always got stories.
Right.
But I have had a guy on Pennsylvania once, he pulled a compressor out, we sold him several in the past, the guy knew what he was doing. And these terminal plates are labeled on the top, they got a letter next to each one. So that's U, V, X, W, Y, Z, right at the base of it. Actually, on the eyelet from the motor, you should have it stamped on there, what that is as well, to go on the right one. But you can set them out, mark them down, put them like exactly the same way, it should work just fine. Again, always still check your rotation, put your gauges on it. I had a guy in Pennsylvania said he did that. I marked them, I've done this 100 times, I put it up, to put it back on, the thing ran backwards. And he got me on the phone, was troubleshooting, I said, well, it sounds like it went backwards. He said, it couldn't. There's no way it could have gone backwards. I did it exactly the way it was. As we kept on talking, I said, well, you know, what caused this thing to go out? Well, we had a transformer went out, and it messed it up, so, you know, we got that fixed, and we had to change out the compressor. Well, the guy on the post switched the phases on the pole. So it wasn't the service guy's fault, but still, I mean, things like that can happen. So that's, always treat it like, I did it exactly the way it should be, but treat it like I need to check that. I need to keep my eye on that when I start, just to be sure. Because you never know who else might have had their hands on it. It's a possibility. Always remove out, lock out, tag out, you know, that's, always follow your safety procedures anytime you're working on one. Recover the refrigerant from the compressor, check to confirm the pressure within the compressor is no more than 2 to 3 psi atmospheric pressure before servicing begins. Sometimes you can, sometimes you can't do that. I always try to tell, I mean, I've been in the field, I've done a lot of things as well. I know what the guys in the book say to do and what you can do. Sometimes it's like you're trying to draw an oil sample. Okay, I can't shut this thing off. You know, this thing runs 24/7. They won't let me shut it off. I need to draw a sample out of this thing. You're trying to draw it out of this valve right here, which you've got discharge pressure on that all the time. Try to crack that open with discharge pressure on it, that freon just pushes right through the oil and you got foam up, you can't really get it out of there. But if you just shut the compressor down just for a minute, it equalizes pressure in there. Then it can go from, I don't know if you're at say 180, 190 psi discharge, it'll equalize out of there and you'll drop down to about 70, 80 psi. So then you can crack it and get a little bit out of there and shut it and get it fired back up again. But always try to get that pressure down anytime you try to draw an oil analysis if you can. Trying to do it just takes forever, and you're going to probably wind up contaminating the oil with moisture because POE oil is very hygroscopic. It can draw moisture right out of the air. I've had a lot of guys that have drawn samples, had several compressors, and it foamed up on me, so I set one down, went to the next compressor, I put a little bit in it, foamed up on me, so I set it down, went to the next one, did that 2 or 3 times, and finally got enough I could do it. Well, by letting that sit there for 10, 15 minutes, you just drew moisture into that sample.
Can I ask a question on that? 'Cause
Yeah.
we had a different, this is the last company I worked at, but we had a little tin can style oil sample.
Yeah.
Because they were saying something about the plastic and the moisture.
You gotta have the right kind of, yeah, you can draw right through plastic.
Okay, because I know when you guys send the kits with these,
Yep.
it's plastic.
It's a neoprene type, it won't draw moisture through that.
So it's a certain type of plastic.
It's a certain type.
Now, I was
Yeah.
wondering about that, I'm like, you guys yourselves are sending plastic, and I heard the plastic's gonna,
It will, yeah. Years back, we did a test on that. We put some in a plastic jug and set it down, and in a couple of weeks, new oil. We drew a sample and sent it off the lab, and it was like 1,500 or so in moisture, parts per million.
yeah.
It drew it right through the bottle, or right through the jug. But what we get is it's a neoprene fiber type, it's a special type plastic, so then it won't draw it through it. But yeah.
Well, I was wondering, so I'm glad you.
And yeah, you get to oil analysis, there's all kinds of elaborate little samplers they get. I mean, you get some that are vacuum metal cans and, you know, you suck it out of there. Well, I'm not saying that won't work, but it's a pretty high expense for doing the same thing. You just want to take as many precautions as you can when drawing that sample to get a good, accurate drawing, so when you get the test result, it'll be accurate. Because I had, like I said, I've had several guys that come back elevated moisture and everything else is good, and he goes, well, but everything's good, my sight glass says it's dry, how can I have moisture? And then we start talking about, well, how'd you sample it? And well, let's draw one more sample, try it again and see what happens, and then it came down. Sometimes it can be an eye opener, you just kind of get in a rush, I mean, you kind of forget that POE oil is very, like I said, very hygroscopic. Okay, features and designs on the screw compressor. Do you guys see all that already? All right, I mean, it's not too, is it too small?
I don't gotta read it.
You can read it on your phone.
Okay. I'm sure I can make that bigger, but I'll be sure everybody can understand what we're saying here. The product introduction, again, this is the 5 series. Introduced in 1973 worldwide. Now, whenever these came over to the U.S. in 1973, it had POE oil, SR30 POE synthetic oil. Now, Hitachi said that was manufactured in Japan, and we can get it, but it was just getting it over here. Hitachi said if you have trouble getting this and you need oil, they will allow you to use 4GS mineral oil. So you want to check your systems, you know, whenever you're changing oil or doing something like that, if you can, to find out what kind of oil is in it. Now, when you do use mineral oil, there is a step back. Your bearing life's less, your vibration may be a little higher, your noise is going to be a little higher, because the mineral oil is so much thinner. It's just like water almost. I mean, it's very, very thin. You get it, it's very cheap, but there is a step back for using mineral oil. And POE oil and mineral oil do not mix well at all. We did another experiment with POE and mineral oil. We put some in a little bottle, heated it up, mixed it up real good. It just coagulates, gets kind of a tan color, gets really, really thick. You set that bottle down, and after a little bit of time, it just separates like water and oil. So if you have a mixture of that in the system, it could coagulate like that, and it could possibly start plugging up some orifices and stuff in the system. So if you're converting the system over one way or the other, be sure to try to get that oil out of there as quickly and as much as you can. Otherwise, you could have some issues. Like I said, I'm not saying you can't use mineral oil, but you've got to have precautions and know what you're getting into by getting the cheaper oil. The compressor may not last nearly as long.
So all the compressors shipped from you guys are gonna have POE in them, right?
Yes.
Okay.
The only time we would ship with mineral oil is if somebody said they have a system with mineral oil and they would like for it to show up with that. And we'll do an oil change prior to shipping and tag it that that's on there, but only if it's requested.
Because I got a couple buildings with that Sunschool 4GS in it.
Either be sure just to drain the oil out of the compressor when you get it, or let us know before, and we'll do the oil change prior to its shipping. Because we want to be sure to get you what you need, but we don't want to accidentally mix oil.
So would you recommend taking that oil out of there, or risk the mixing them, or would you let it sit and run it?
Personally, I would get it out of there.
Okay.
I would put it, do an oil change on it, and then run. Just try to get a little bit of a mix on it. Get maybe 10 hours on it. Do another oil change. Depending on how big the system is, how much piping you've got, you may have to do another one. Usually there's about 20% of the oil charge up in the circuit after you pull the compressor out, put a new oil charge out, put a new oil charge in. But I then would get another some more hours on it, get run time, and then draw a sample on it. The lab doesn't test for type, but it'll test for viscosity, and there's a big difference between the two. The viscosity on mineral oil is about 40 to 60, and POE is about 220. So if you come in really low on your viscosity, it's like, well, I may have some mineral oil still in there. But if you're getting up there where it should be, then you should have pretty much converted over.
Okay.
Now, like I said, it's not the cheapest oil. It's very expensive, but it's a much more protective for the compressor, the life of the compressor, and keep your capacity up. On average, these compressors should give you 25 to 30 years. You should be able to run a Hitachi 25 to 30 years without having to change it. If you got compressors in a system that are dying out every couple of years, I'm having to change the compressor, something's wrong in that system. You can keep changing compressors. That's what I do. But I'm here to to provide you what you want, but also to provide you that tech support so that you're a hero to your customer and you're not having to do that. Maybe they have been pulling them out every couple of years and you came in there and found out what's going on and got it fixed, and now I'm not having trouble anymore because these guys fixed it. It's kind of the nature of the beast for both of us. I mean, I gotta sell stuff to keep my job, and you guys gotta do service work to keep your job too. But you get return customers if you go out and you fix it right, and it's still working good. They'll call you back for anything else. So it may not lead you more business for that one unit, but it'll lead you more business for that customer. That's my philosophy anyway. Plus it keeps you and your company a good reputation. Let's see, where do we off here? Hitachi compressors has an overall failure rate. And that's one thing, yeah, we do, we have been able to maintain this. Our failure rate's less than 1% on the Hitachi screws. Normally, you know, and I never second guess something, but if something fails very quickly, you know, we'll bring it in, we do a tear down on it, we find out what's going on with it, and we'll let you know. But most generally, it's the system that killed the compressor. If somebody says, especially a rebuild, says, well, this thing showed up DOA, I put it on, it started, it didn't even run, this thing's dead. Something usually else is going on. And I never discount that it can't happen, but historically it really hadn't hardly ever happened. So we have a real good warranty rate on our compressors, which I'm very proud about. And like I said, I've been with the company now going on 23 years. That's why it's easy for me to stand up here and brag about the Hitachis, because they have been, and they are a good compressor. If I was trying to push a very cheap compressor, I'd find a little guilty conscience to be able to stand up here and do that every day. But these things are a very good compressor. Features. More enhanced product features, we don't even know that. We'll go back to that. The screw slide there on the bottom just kind of shows how the screw compressors, they're a male and female screw rotor in these compressors are a married set, which means when these things are milled, you can't take a male screw rotor out of one and a female out of another one and put them together in a compressor. It won't work. These things are made as a set. The tolerances are that tight. You just can't mix and match them. They're very high quality, very hard to get to go into another compressor. So if you had one that was messed up a little bit, the entire compressor needs to be junked. You can't really save it. Screw compressor versus reciprocating compressor. Screw compressors are just a much better compressor. There's so many more moving parts in a recip compressor. And I mean, they've got their place in the market, don't get me wrong. I'm not knocking reciprocating compressors, but a screw compressor is just more vibrant, more heavy duty. It can just take a lot more. There are a lot more moving parts in the reciprocating compressor, like the pistons, connecting rods, slide valve plates, the oil pumps, mechanical linkages, capacity control. That's another thing in the screw compressors. There is no oil pump in these compressors, which eliminates a big part right there. It works off differential pressure, which means the difference between your suction and discharge pressure, your high and low pressure. It's got to maintain at least 70 psi differential in the compressors to oil properly through that compressor. So if you have a controller or something that can monitor that, you want to be sure to monitor the 70 psi differential. If it sits there running about 40, of course that's not too hard to do, you know. But if you get down there 40, 50 psi difference, you're not going to be oiling properly in that compressor. But if you've got that close of pressures, then something else normally is wrong. If you've got that low of discharge pressure or that high of suction, something else is going on in that system as well to get that close together. I mean, you're talking, you know, 70 and 140 is all you got to be to get your 70 psi differential. I mean, should be no problem doing that.
So is that minimum, 70 psi?
Yes. And normally, we do offer a solid state controller as well, if you guys ever are interested in something like that. In the controller, it looks at that differential pressure, and what we do have is like a 45-second delay, because sometimes it may drop and come back. If you got, you know, condenser fans kicked in, for some reason the discharge dropped for a little bit. Now, okay, now it's starting to come back up. So it'll go into a delay and start timing out, so if it goes for 45 seconds and does not get back above 70 psi, then it'll trip it out. But you know, if it gets down to 65, it's not going to trip it out immediately. It's going to start that clock and start ticking. And if that pressure comes back up, it'll just go back out and it'll reset itself again. But if it stays down there, then it'll trip it out. Range, resistance to slugging. Of course, no compressor should ever be exposed to liquid refrigerant. A reset, of course, I can just knock it out as soon as it hits it. Now, a screw compressor, it won't kill the compressor. The slug itself won't kill it. It'll compress it, it'll push it right on through. But what it does is it does a wash effect. It washes the oil off the bearings, the screws, the rotors, so that you don't have any oil on it then. And then you're going to start getting friction buildup. And then that'll kill the compressor, is that wash effect. So you want to be sure to not have too low a suction superheat, because that will cause it to get liquid in there. Like I said, it'll keep running, it'll push it, but you'll wash all the oil off and you get friction, and eventually you'll lock the compressor up. But it will give you some time. I mean, it'll still run, but a reset, you plug it with liquid, it'll knock it out just almost in a heartbeat. Improved lubrication system, we talked about that already a little bit, about there's no oil pump in the compressor. Screw compressor advantages, a pair of patented profile screw rotors, which we talked about that. The technology is just a married set. Built-in oil separator. Patented double wall construction for the decrease in the noise, vibration sound. The type of number of roller bearings used in the positioning of the screw rotors, the axle and actual thrust on this. You've got bearings on both sides. I'm not sure you guys can see that over here, but yeah, a little bit. I want to take a break. You guys can look at. There's a triple set over here. There's two for the female, and a triple set on the male over here. There's also a set on both ends, so it's steadied on both sides. There's really no way that compressor should be able to go anywhere. It's very well stabilized on there. This is the slide valve that sits on top of the screws, and as it works as a hydraulic motion to push over the screws to increase capacity or come back off of it to decrease capacity. This is the piston cylinder where the piston is, and this piston rod that connects the two. Right here is a partition between the compressor that blocks the pressure, because over here you always see discharge pressure. And that cylinder is going to go up and down as you load or unload the compressor, so that's got to be a sealed cylinder. And normally, I know I'm going to jump around here a little bit, but normally your biggest culprit will be copper plating. There's a little slip ring, Teflon slip ring that seals around this rod that pushes in and out. If you get copper plating that can build up on that Teflon slip ring and break the seal, that allows that discharge gas to bleed back into the cylinder, which will cause the compressor to unload by itself.
What you say if you get what?
Copper plating.
Copper plating. Normally copper is one of the biggest culprits of these, especially with POE oil. Copper plating is normally from either your system's become acidic, which if you get moisture in the system with POE oil, it gets heated up and start becoming acidic and starts dissolving the interior piping. It's going to flow around and stick to the highest heat source of that system, which is that compressor, the ball bearings, the screws, the slide valve, all that. It's going to start plating on that. And normally the only other scenario for copper plating is we have copper pipe that's flaking internally. Seen that where the guy goes, well, it's not acidic, we did a sample on it, it's not. It's almost got to be old piping starting to flake internally. There's not much you can do about that other than just try to stay on it, keep oil changes on it, keep it monitored. About all you can do. Without going in there and cutting out all the piping and changing all the piping on the thing.
What's the average life on, I mean, we've had a few as well, what's the average life on a system that's running right for that slip ring?
25. I had original compressors that are out there 25, 30 years old that are still running.
The slip ring too?
Yeah, never been touched. Other than do some oil changes and service work on it, but never had a slip ring have to do it. Again, if you have a tight, clean system, copper shouldn't ever be an issue. If you got copper in there, there's something going on. You're getting contamination introduced to the system, or old piping is starting to flake for some reason. And I have had some epiphanies over the years where we had some samples guys drew. You actually look in the side glass and you can almost see glitter, little glittery flakes in the oil. It's like, well, I can see it in there. We drew a sample, came back, the sample came back low on copper. It's like the copper came back, didn't show as high on copper. He goes, I can see it in there. I can see it glittery floating around. So I was kind of confused by that as well, and I called the lab and told them about the situation. And they said, well, whenever you get the copper in the oil, it has to be dissolved in the oil for this test to pick it up. If it's particulate copper, little particles floating around, and it hasn't dissolved into that oil, it may not pick up on your oil analysis. So if you see little flakes of copper floating around in there, that's just a red flag right there. You need to get it out of there. I mean, it's okay to draw a sample, and you still may get an elevated sample or an elevated reading on it. But I have seen a couple of situations where it was particulate copper in the system, but it wasn't dissolving into the system because it wasn't acidic. So even though it's flaking, it wasn't dissolving up and getting embedded in that oil, which was totally confusing to me to start out with the lab. I kept arguing with them, but you can see it. How come I'm not getting a reading on that? Well, it's not dissolved in oil. Our instrumentation doesn't pick it up. So.
That'd be part of the test. Particulate.
Visual,
Yeah, pretty much.
visual debris.
Yeah, exactly. Again, an improvement is the improved lubrication system. That's the differential rather than having the oil pump in there, so you don't have to worry about that. Rapid oil foaming does not occur in Hitachi screw compressors because the lubrication is stored in the high pressure side. Like I said, and that oil sump is always exposed to high discharge pressure. Hitachi screw compressor advantages. Let's see, we went across that already. Here's a cutaway of the compressor. Basically what you see over here is up here, shows some of the components of the compressor. Right here where the turn handle is, you should have, as a suction line connects, you should have a suction strainer that goes in right there as well. There's also an oil strainer down here. There's an 80 mesh strainer up here to catch any particulate coming in. As the oil flows through here, the Freon, it comes through, cools the motor. That's what keeps your motor cool, is that flow on the Freon. And then there's a 150 mesh strainer down here in the oil sump. If you're doing an oil change on a compressor, it's about, that oil strainer is always a good idea to pull that out. It's a 4-bolt plate, get a gasket and O-ring, so you can pull it out, change it. Really, it's metal mesh, so on an oil change kit, we don't put a metal mesh strainer in with it, because normally you can clean it off and just put it back in if it's got debris on it. But you should be able to put one finger on it and slide the whole thing out. It should slide out very, very easily. You get one that looks like this. That's wrong, something's wrong. Or if you put your finger on it to slide it out and it doesn't come out, that's probably what happened. It collapsed and it's hitting, trying to come out. You've got to have to rip the thing out to get it out.
Collapse because there's just so much crap on it.
It's usually one of two reasons. Either we got so much debris on it that's collapsed it, or we had a rapid change in that sump for some reason. Your discharge pressure for some reason just shot through the roof very quickly. That can collapse it as well. Doesn't happen that often, but it can happen.
You got that magnet tucked back behind that too, right?
Pardon?
These compressors, they got that magnet tucked back behind?
Yeah, once you slide this thing out, the strainer out, if you look inside that hole, there's a magnet about a 1/2 inch round, about 4 inches long. It's always a good idea to get a long screwdriver, slide it in there, let it attach to it, and slide that magnet out. If it's got a little bit of metal on it, clean it off, put it back in. That way you know the next time you open this thing up, you can check see how much metal's been attracting. A little bit on a new compressor, you've been running for a while, a little bit's not that alarming. I mean, it'll be there. It's kind of like a new transmission breaking in. It'll be a little bit, but not a lot. It shouldn't be a lot. But,
Hey, one more question on oil. We cracked things open a couple times, there's some fiber in there. And we called you guys, they're like, yeah, that come off the windings.
well, what's
So
probably...
what causes that? I mean, why, is that a natural occurrence, or is there?
Not so much the windings, but if you look at the, these leads off
Okay, it's
the...
just off the lead, off the turn, okay.
Yeah, it's got a, you know, it's like a woven jacket on there, like a nylon jacket. And if up at the top it starts getting frayed a little bit, or for some reason it's starting to come undone, that's where it's gonna come from.
So if we see that, is there something going on? Is it the oil, bad oil, or just wear?
It's just wear.
Okay.
Velocity coming across that is finally starting to, you know, wear into one of those fibers, and like anything woven like that, once you break a couple of strings, they're gonna start trying to come undone on you. Now normally it's not gonna do, you know, really mess up anything, unless it gets bad enough that, enough of that comes unwoven, we got bearing wire exposed, and there's a possible chance it can touch somewhere. We also have these insulated rings around there, slide on there for just that extra protection, so that like gas comes through there hitting that, it's gonna hit that rather than hitting right on that nylon. And that nylon has a coating on it, so normally, I mean, we've got some there, we've gotten, that have been, 20, 30 years old, come in and they look just perfect. They've never done that. We have seen that happen, where if you get a stringy material, that's 99.9% of the time, that's where it's coming from. It wouldn't be like, I gotta get this thing out of here, it's gonna fail on me in a minute, but you wanna monitor it.
You were seeing it on the wheel screen?
Yeah, you pull it out, you wind up seeing little strings or something around that strainer. That's what that'll be coming off that. Now, if you got a whole handful of it, then it'd be like, oh, no, we better do something. But if you got just a little bit.
Re-shrink wrap it or something?
You could put some heat shrink on it, just be sure it's on there very good and very tight and approved for POE oil and all that, so it doesn't dissolve on you. Yeah, that'd work. Or you can get in there just at the very top and start to fray, you can heat that, to try to, how you can heat that rope, seal it back up again, keep it from fraying more. Those are just optional things you can do. Let's see. The semi-hermetic motor, like we talked about before, is running 50 or 60 hertz. 3470 RPM at 60 hertz, runs a 2880 RPM at 50 hertz. That little separator. The load and unload is basically a hydraulic function. It takes oil in and takes oil out to load and unload the compressor in that cylinder. Let's see, we'll get to another better drawing here in a minute. Yeah, here's one. You got 3 solenoids on the compressor. They're right in the center. You won't see them on the cutaway very easy. They're right here in the middle. Stair step from bottom to top. The bottom being A, the middle one being B, the top one being C. 2 series, 5 series, all of them. The C, the top one is always your load solenoid. And the 2 bottom ones are your unload and rapid unload. On the 2 series, let's see, what's this one? This is on the 5 series. The 2 series, the B is your rapid unload, and A is your normal unload. So on the 5 series, those two just switch. So A is your rapid unload, and B is your normal unload. Now on this diagram, you can see where A, you put oil in the cylinder to unload it. So you'll fill this cylinder up, and that pushes that piston back. So you energize the A solenoid. There's no capillary tube on the compressor. There's 2 small 1/8" capillary tubes on the front of the compressor, which regulate that flow of oil. So when you energize the flow of oil, it slowly loads it up or slowly unloads it. And when you energize that rapid unload, there's no capillary tube. It goes through an internal journal, about a 1/4 inch internal journal, so it puts the oil in there pretty quickly. Puts it up, goes through the A solenoid right into the cylinder. Coming from the sump, B goes through the little capillary tube to slowly unload it. Or C, you take the oil out. This evacuates that out to that cylinder, back to suction to unload or to load the compressor. So when you put oil in that cylinder, there's ports on the side. We'll show you where they're at here in a second. In that cylinder, when you're at full unload, that cylinder should be right at discharge pressure at the time. So when you're sitting there looking at your compressor, you're checking these pressures to find out, well, am I fully unloaded or not? You can look at your amp draw, but if you want to be sure, you can check the pressure in that cylinder. It should be right at discharge pressure. That means it's filled out as full as it can. And a full load, it'll be right at suction pressure. It means it's evacuated all out of there back to the oil sump, and you should be fully loaded. But I wouldn't go off that oil pressure as to what percentage of load you are or anything like that. You want to do that with your amp draw, not your oil pressure. If you want to just try to confirm, am I fully loaded, am I fully unloaded? You can check that cylinder pressure, and that'll tell you that the pressure's gone as far as it can go.
Where do you check that at?
Well, I got another drawing here. I'll show you. There's a port on the side of the compressor that you can connect to. It'll tell you that it goes right into that cylinder pressure, so you can check that pressure. Again, I'm kind of jumping around here a little bit on you.
You're at.
Then when you take the oil out, it allows this slide valve to try to start pulling across. You take the oil out, it starts pushing across here, which allows this slide valve to slide over the screws to increase the pressure or increase the capacity. Excuse me. So when you unload it, put oil back in here, it fills this up, it starts filling that cavity up and pushing this piston back, which draws that slide valve back off the screws to unload it. So it's very simple procedure.
So with that spring in there, does it automatically, when it's off, go to full on load?
It won't do anything until you energize one of the solenoids. So if I shut this thing off at 50% load, I fire it back up and nothing gets energized, it's going to fire up at 50% load and that's where it should stay. That's why anytime you have a controller, you should always have it so anytime the compressor starts, you energize that forced unload for about 30 seconds just to ensure it gets fully unloaded. Then that controller can take over and say, okay, do I need to stay here or do I need to start loading this thing up? And it helps the inrush on when you start the compressor too. So if you start off, shut it down at full load, boom, this thing shuts off. You try to fire it up at full load, your amp draw is going to be a big inrush.
It's still going to fire up at full load for a second or two.
Yeah. Yeah, it'll fire up, but if you energize that forced unload, when you energize the compressor, it automatically just starts coming down very quickly. So it'll make all the difference in the world. You want to be careful when you're troubleshooting these too. I've had unfortunately, several times over the years, guys have called me with one and said, this thing will not load up. I haven't got copper in this thing, but I can't get this thing to load up at all. And I've actually gone on site before, and a couple times I found where when it energizes the load and unload at the same time. So it's not going to do anything if those two are both energized at the same time. You got to be sure we're not, you're checking to see, is this loaded up? Is this load energized? Yeah, okay, it's energized, but make sure the other two are not. I mean, again, some of those simple things can get you.
How is it pushing, like, look in that diagram there, that spring's trying to push it towards the unload, right?
Yep.
How is vented to the suction pushing that thing in?
In this compressor, the gas comes in through here,
Right.
comes in, gets compressed, comes up through the back side here, and then goes up through a port on the far side. This gas coming up through here is always pulling or pushing.
The suction.
Look at that slide. I was trying to push it over the screws all the time.
Yeah.
So you're filling this up, and then it pulls it back off of it. So you take it back out. It allows that to still draw that over. The spring just keeps it from trying to slap over that way.
But there's gotta be pressure on the right-hand side of that piston.
There is a certain amount of pressure, but not as much as there is over here when it's running, trying to pull it off and then pull it over the screws. When I first started, I couldn't understand that either. That's one of the first things, was like, that doesn't make sense to me. You think whenever this thing is empty, this thing would slide back over and pull it back off, but it doesn't. It pulls it back that way. It's the velocity of the gas coming through or getting compressed, and it's always pushing that slide out, trying to push the slide out over the screws. Yeah.
Okay.
It's a good question, because I was the exact same way when I first started.
Both suction, both.
Well, yeah, cause you
Suction
look at
pressure
the
on the
right-hand
sides.
side of that piston on the diagram, like that's vented to suction.
This has been the suction on the backside, but you'll never see anything back here. Whenever your oil is always going to be in here where the spring is. This is sealed by a Teflon slip ring as well. So on the backside here, you got a little hole there just to keep it vented, but there's nothing, you'll never have anything in there. Your oil comes in here, pushes it out. When you load it up, it comes back out through here and out, then allows that to slide over that way.
Just because the force of the screws is just naturally trying to pull it that way.
Right.
Oh, the force of the screws on the big slide valve. Is that what you're saying, Steve?
Right. Slide
That's what
valve,
he's
it comes through here.
So, okay.
This comes out, there's always a minimum amount of load. It doesn't go down to 0%.
So the screws are trying to actually suck that slide valve over it.
Yep.
And then you're just regulating it through the pilot valve on that piston.
Right.
And so okay, that makes more sense.
You can't compress the oil.
Yeah, because it seems like you'd be using that piston to pressurize one side hydraulically and force it against the spring, but that's not what's happening at all.
Really, you're hydraulically forcing it back off of it.
Right.
Then when you take it back out, it allows it to draw itself back up. And that spring will compress, but this is always going to be a certain amount over the screws. I think your 50 and 60 horsepower go down to 25%, and the 40 horsepower goes down to 33%. So you're at full load, you still have a percentage of load going on. It doesn't go down to 0.
hydraulic cylinder, forced to twig.
Yeah.
It's pretty simple design.
And the spring was just a fail safe or like a spring return on actuator, just brought it back.
So if you have one that doesn't load up, will it load, and if you energize your load, will it load? And then when you take power away, it'll instantly unload, if that slipper ring is leaking, or will it not load at all?
Depends on how advanced the copper plating is. Normally copper plating, you'll get to where it will be kind of hard to load. And maybe when you it'll load up, then you de-energize, it'll maybe slowly start coming back. And it may, on the rod where it builds up on the rod in a certain spot, it'll hang up. If you ever get pushed past that, it'll load on up. Then it comes back down and may hang up again. Then it'll, do that, and then eventually it'll load up, but then it'll unload down by itself. Then eventually get where it won't load at all. It just kind of depends on how far progressive the copper plating's got. So,
Is that something that can be repaired in the field?
yeah, we got what we call a slipper ring replacement kit. And then your manuals in the very back, there's a copy of the manual that comes with those kits.
There's a whole video that Todd and I did a couple years ago that breaks down
Okay,
step
I'll show you.
by step.
Right here. This is the ring.
Right.
But what I've noticed is on the controls, our controls guys love our controls guys, but
Fire.
they sit there and
We all do.
they're trying to hold it to a tenth of a degree or a degree and a half or whatever on a building that's, 55-degree discharge air temp or 52 degrees and they're,
Give me a dead band, guys.
yeah, they're constantly hitting the load and unload and load and unload, and it always wears in that same spot. Because that compressor's riding right there, the slide valve is. It's like, and it just wears it out.
Or something like
Yeah,
that.
you need 5 degrees or something.
Yeah, 3 plus or minus.
So if you guys are replacing slipper rings, just watch that because that's 90% of them,
Is there
why they're
anything
wearing
else
out.
that can give you like a false slipper ring? Like if you're low on charge, or if you're running too cold condenser water, discharge pressure's not high enough, or is there anything else that can cause the same non-oil pressure in that cavity?
Not so much in the cavity, I don't think. Normally, if we've got one that won't load properly or unloads by itself, it's one of two reasons. It's either that slipper ring or with the solenoid valve. One of the solenoid valves, even though it's not energized, it's bleeding by. It's not, came down but didn't seat up. Those are usually the only two reasons that compressor will not load properly or load up properly. Doesn't hardly ever happen, but say a guy calls, that's normally what happens if they call and they've got a load problem because it unloads by itself or won't load up properly. The guy calls and says, hey, this thing, sorry.
That gets you going.
If the guy says that this compressor load up by, it start up, it just loads up by itself. It could be a solenoid stuck open, the solenoid, load solenoid stuck open. If this piston slipper ring around this one got notched or something where it's leaking past that piston, then it would vent to suction and do like this, the load solenoid would cause it to do. But like 23 years, I don't know if I had, maybe one or two times that's ever happened. Not saying it can't happen, because as soon as you say something like that, it's like, well, heck, that's gonna happen next week. But that should never happen. Here's kind of more of a aerial view. Start looking at the top of the compressor. Like I said, they're kind of stair step from bottom to top. A, B, and C. This is for the 2 series. Like I said, the 5 and 2 series, those unloads just change places. I've got a shot like this for the 2 series, the 5 series, and then I've got a shot on here, a page that's got the 2 series and 5 series next to each other. So you can kind of go, I know there's a difference there, but if I go from page to page, you can kind of just look at the page and see. Just the operation sequence for the solenoids. And again, start stop, which is your rapid unload, fast unload, rapid unload, start stop unload. People call it several different things. It's just that what's going to unload that compressor quickly. Is your B solenoid. To load it up will be your C only. Unload is your A only. And constant load, which means this thing is not doing anything, will be they're all off. And again, when you load this thing up, wherever it stops, de-energizes the solenoid, that's where it should stop and it shouldn't migrate on you. Now, if you're looking at your amp draw, of course, pressures in the system, you may see 1 or 2 amps. It could fluctuate up and down a little bit. But if you see the amp start just changing and going one way or another, then that's when you got a problem. Something's not going right. Again, like I told you, the compressor is fully unloaded or not at 0. Your 40 horsepower compressor is going to go down to 33% at full unload. Your 5 and 15 and 60 horsepower will be at 25% at full unload. Amp draw is really the best way to look at these compressors to find out where am I at as far as full load or mid load. And when you look at the nameplate on the compressors, you're not going to see full load amps on the nameplate of the compressor. You'll see lock rotor amps, that kind of information on there. The reason you don't see it is because these compressors can be put on water-cooled or air-cooled units, which you're going to see a lower amp draw reading on a water-cooled unit than you will on an air-cooled unit. So you want to go to the nameplate on the unit, and that'll tell you what the compressor full load amps should be in that unit. So never look at the nameplate on the compressor because it's just not going to tell you. Go to the nameplate on the unit, and that'll tell you what full load amps should be on that compressor in that unit. There's just another more detailed line out for minimum capacity. Kind of shows the flow chart on how the solenoids work. Again, it's just a hydraulic function to load the compressor up. You evacuate it out, which allows this to slide over. Like here, load it up, unload it, you're just putting oil in that cylinder, and again, just a hydraulic function. You're using oil to drip into that, fill that cylinder, and push that slide valve or the piston back, which pulls that slide valve back off the screws. Make sense? Pretty simple stuff. These are pretty simple machines. You guys, I'm sure you guys have probably worked on these kind of machines quite a bit. I get a lot of guys that, if you're new to it, you see a 1,000-pound compressor, you're going in there to work on it. It can be kind of intimidating, but they're really pretty simple. They're very, very simple, which is what I really like about it. Here's the 5 series compressors. Again, same thing, only we always look at them as A, B, C. We're talking about the solenoids. A on the bottom, B, C. Now the start stop on this one is the A solenoid, the bottom one, instead of the B. So we looked at the one just prior to that. 2 series. Start stop was your B solenoid. So it's just those 2. And again, you don't have to remove the valve off the compressor, just that electrical coil to swap them. Because all the valves, the load and unload solenoid valves are the same on all the compressors. Go back again. If you look at the on the base of each solenoid valve, there's an arrow. It's not on the compressor itself, but on the valve that mounts on the compressor, there's a little arrow at the base of that valve. Again, all these valves are the same. All 3 of them are identical. But you want to be sure to get your arrow pointed the right way, because the 2 unloads on the 2 series go one way and the load goes another way.
On the base of the solenoid valve, there's an arrow? So that you pull the stem off and it's right there on the plate, the 4-bolt plate?
Well, it's a little 2 bolts.
Or 2-bolt plate?
Yeah, right there at the base of it, there's a little arrow pointing one way. So be sure you get your arrow pointed the right way.
Hey, Brian.
Must have got lucky.
You must have got lucky, huh?
Now you know.
Is there a?
Shit, you could really screw that
average
up, changing the
time
gasket
frame
then,
for
huh?
Load and unload guideline, I guess, if you were gonna check one so you could tell. if
Depends
you were
on,
in there.
they're controlled differently on how, if you pulse the signal or if you give it a solid signal and all that. On our test stand, we manually do it. So normally, from full unload to full unload, of course, our first load is usually a little bit longer because it's kind of oiling up that cylinder for our first run. When it's fully unloaded, we give it the solid signal to turn power on that low solenoid, sit there and let it go to full load. That usually takes between 2 and 2.5 minutes. Now, the second time, you load it up, you unload it back down, okay, now we're gonna do that again. We're gonna load it on back up. The next time may only take about a minute, 15 seconds, something like that. So it usually shortens. After, it's in service, it should be about like that. If you just put a compressor on, you're looking for that first load, it may be a little slower the first time.
But after, like, if we went up and we were working on it, up and running, and we were gonna test it, load to unload, about a minute should be per load. I mean, if it was taking 2-3 minutes or shorter, I mean, would it indicate?
It could indicate a couple things. It could indicate we got some debris in the journals of the compressor, you know, restriction of flow. Could be the oil strainer. The oil strainer's gotten restricted, so it's flowing, but it's not flowing very, you know, smoothly. Something like that. But yeah.
Or if you can't load at all, your oil strainer could be getting plugged.
So, I'm sorry. Say it again.
If you can't load at all, it could be an oil strainer issue, not for sure a slip
It
ring
could
issue.
be. It could be because it's can't get the oil back out of there to, you know, get out of that cylinder.
Yeah, I missed the question, Brent, were you talking about after you do the slipper ring rebuild, it taking a long time to load up right away?
No, I was just wanting to know, is there a guideline for time from
Maintenance.
from a fully unloaded to load and then load to unload? Is there an average time for those two scenarios?
1 to 2 minutes, giving it a solid signal.
But for not unload though, it's a lot quicker.
Unload should be, yeah, usually it's a little bit quicker, maybe about 45 seconds, something like that. 30 to 45 seconds on a full unload.
Hey, on that same thought though, it's been a while since I did the slipper ring, but it seems like right after we did it, fired it up, put it on load, and nothing was changed, and I was like, oh crap, what's going on? But finally it loaded, and after that it would do regular things. But the first time it seemed like it took forever to load up for the first time after the rebuild.
Yeah, because it seems like when you do the slip ring kit, you put a new slip ring on your piston, you put a new slip ring here.
Yeah.
You got this out, you may wipe that out, so it's now kind of, you know, it's a dry cylinder now.
Mhm.
So yeah, that first time it loads and loads, it's gonna take longer. And after it does it once, it'll be quicker.
Yeah, it usually did after that, it just, you know. maybe the
First time it's like,
I did
oh,
it,
is it gonna work?
I was like, no, that worked, and crap, I did it wrong.
I don't wanna turn this thing back over to
Big
you.
pressure.
Yeah.
Yeah. All right.
Hey, I apologize, I came in, I went to the restroom real quick, but the
Yeah, it's
arrow
okay.
thing, can you explain it one more time?
What's that?
The arrow thing you're pointing,
Yeah.
so, on top of the little, like, if you, this is solenoid itself, and you replace that, or?
Yeah, the solenoid valve body, at the base of that, it's got 2 screws on that hold it down to the casing. At the base of that solenoid valve body, on the base, there's an arrow pointing one way. So if you see on, let me go back here. Well, let's see.
Cause that's a common leak point, those gaskets.
Yeah.
So if we switch that around on it, it won't work, right?
It might, but it won't work very well.
Okay.
You know what I mean? It's a one-way valve, but you got oil up on top of it, you open it up so it can go back and go through the other one. Now, if it's enough pressure, it may force it up, but it won't work very well.
So there's an arrow on the body and an arrow on that cap you gotta meet up together, or?
It's not on the compressor, it's only on that valve.
You should look at the drawing.
That's why,
Wow. I never even looked.
I got a better picture on down the line.
Right
Like
there.
on this one, you can see the arrow on the unloads going this way, the unloads going this way, the loads going this way. So when you pull it back off, now you can use your manuals, you can see which way it's supposed to be. If you go, I pull that off, I don't know which way it's supposed to be. I mean, you haven't got another compressor to go look at in the same unit. In your manual, you can look on here to see which way your arrows are. I got another drawing that's easier to see.
Are they the same on the 2 and the 5?
No.
Oh, because the ones are switched. 2 of them are.
Actually, I believe the 2 unloads here, one's going the other way, this one's going this way. Load's always going the other way.
Yeah, cause I replaced the 2 gaskets, and I just took it off, one new gasket, put it back on, but I must have held it just, it still works. Yeah, that's interesting.
It must be a small arrow, nobody's seen it.
Yeah, it is, you really gotta look for it. It's raised in, it's like imprinted on or something, there's a little raised spot on there, I mean, it's there. When you look at it, you'll see it, but it's not something that you just, you know, normally see, you slap it on there, put screws on, and cap it off. And again, like I tell you, I've got some information in here on the 100 horsepower compressor as well. Here's the load unload for that. 5 series. Okay, here's what I was telling you about the load, 5 series and 2 series next to each other. So in case I don't want to flip back and forth, he said, yeah, there's a difference between the two. I got a page that kind of shows you the both, the 2 series and the 5 series. This also shows the arrow. You can see here on the
So
5
A is
series,
different.
A
Okay.
goes this way, B goes that way. On the 2 series, both A and B go this way.
Huh.
So they do go different.
Start and load.
Yep.
Start and load.
You got your sequence of operation down here as well.
Give you something to look at for me.
Yeah, you want that World Trade Meeting? Some repairs coming.
There you go. I like this sheet right here. I mean, the others are good. They kind of show you how it all works and everything, but this is a good comparison, back to back, showing each one of those series.
So why they change it for? I mean, all these years, what they gotta do that for?
I have not a clue.
This is the,
There's several questions I've had over the years of why would you do that? I don't know. I had them over.
engineer got mad at somebody.
He's
Simple,
getting ready to
simple, simple
switch
things come to
companies.
mind.
So when you guys send out another compressor and it's an 05 series, do they tell you? Did they tell you? Does you send out something saying that this is a 5, check your load and unload?
It comes with, it's a manual. I mean, we talked to them on the phone prior to putting it in and all that. And hey, you get a tube, what are you pulling out? 5 series, okay, be sure to change these solenoids.
Okay.
You get a manual, shows you that. The manual comes with it, but sometimes, that will get chucked. You get the work done,
Are the 2 series the ones that have the oil port or the oil sight glass on the discharge side?
Down here,
Yeah.
has to be the 1 series.
Oh, okay.
That's the one that, the old original,
Yeah.
way old.
I had one of those.
Yeah, that had the sight glass right here, was down here on the oil separator.
Right.
I ain't seen that.
There's no sight glass there, so you're like, go and check the oil. Like, what the heck?
Yeah, and why would you put an oil sight glass up here on the separator? I didn't figure that one out either. And I went over for years, they got a sight glass with a little cage on it. And I don't know how many times over the years I've had calls of, I can't tell if this thing's full of oil or if it's empty. And if you get above the sight glass and it's got good clean oil in it, it looks like it's just clear. It's like, is it above it, is it below it? I don't know. They got a little cage in behind it, and I told them, well, why don't you put just a little pea in that, a little float pea? That way you'll know. What's that gonna cost you, 1/4 cent a piece, But these sight glasses screw in about 3/4 of an inch to an inch into that casing. So if you ever have that problem of, hey, I put oil in this thing, walked away, came back, man, I can't, where the oil goes, is it above it, is it below, I can't tell. Usually if you shine your flashlight in there, you'll see a puddle at the base, if it's below it. You look in there and it's just solid clear, I don't see nothing in there, it's a little bit above that. And this oil sump's got a lot of space in it. So if you're a little bit above the side glass, that's not really an issue. Now, you don't want to put 5 gallons in here. 2 gallons is a full charge. But I would recommend, when you do oil changes, put 2 full gallons in there, which may bring it a little bit above the side glass. But when you run the compressor and start loading the compressor up, that oil level will drop down into the side glass, and then you'll be able to see where it's at. But, yeah, if you have an issue, shine your flashlight in there, see if you can see just a little puddle at the base, a little stress, because you will if it's below it.
Donna, do you ever have people call you about the oil washing out under full load, where you don't see it in the?
Not very much.
So do you guys sell the oil level controls for the Hitachis?
We
Oil
haven't.
float, the safety?
We haven't. We could incorporate that with it.
Well, I
You want a delay on there because you do get agitation sometimes,
Yeah.
where it goes out and comes back. What I always teach in this is you always want to see oil in the side glass at all times if you can. Now you will, realistically, you will see agitation where it'll drop out, come back, drop out, come back. If it drops out and comes back within 45 seconds, you're okay. If it drops out for more than a minute and doesn't come back, you need to add oil. Even when you unload the compressor, the oil comes back up pretty high.
Right.
But when I load this thing full up, it's gone. It's gone. It didn't come back. Add some oil to it. For some reason, we're trapping somewhere or something like that. So we want to be sure to try to have, even though you're at that bottom of that side glass, right at the bottom, you're still going to be, the strainer's still going to be submerged. But you're right where we're starting to get very concerned. You don't want to be below that strainer. So you want to try to keep it there. And again, realistically, you're going to see agitation. Usually at full loads where you're going to be at your lowest point. When you unload the compressor back down, then that oil should be returning, your oil should start coming back up. But at full load, you should be at your lowest point, and that's really where you want to check your oil level to find out, am I going to have adequate charge in here? If I get this thing up to 100%, let it run for a while, stabilize, okay, where's my oil at?
So what's the highest at full load you wanna see it to know you're not got too much when it drops down.
Right. Just if you can see a level, that you can see at the very top of the side glass, we're good.
At
What if
full
it's
load.
completely submerged though, let's say,
I drain a little bit back out of there. If it was full load, this thing still seems completely full, I'd probably go ahead and drain some out, because I have drained 5 gallons of oil out of the compressor before. For guys, got a core come in, the guys kept saying, well, I thought it was empty, so I put another gallon in it.
well,
So I put another gallon in it.
so that smoked it.
So full load right at the top, where you can see it's just at the top, that's okay.
That's
Because
fine.
when it unloads, it's gonna climb.
It'll be above the side glass.
That's okay then?
Alright.
And that's okay?
Yeah, that's okay. Like I said, you got a lot of room above here where you could have 2.5, 3 gallons if you wanted to. It wouldn't really, it's not gonna hurt the compressor. But I'd rather have a little too much in there than not enough.
When did it start hurting it?
When does it start hurting?
At what level?
If we start flooding your motor cavity,
Okay.
you start bogging that thing down,
Alright.
that's when you probably.
Hard starting.
Never done that analysis and start draining it out, find out just how much is too much, but you
Yeah.
can go over it, and being the POE oil is very hydroscopic, like we said, whenever you do an oil change, you get 2 gallons of oil in the oil change, if you get an oil change kit, it's got 2 gallons of oil in it. That's right at what the charge is of the compressor, so we recommend putting the 2 full gallons in it. You don't wanna put a gallon in it and put a half a gallon in it and go, well, that's good, I'm just gonna cap this off and set it over here. That
What
oil
can
will
we
go
drain
bad.
What can we drain 1.5 gallons out of your old one? Your old one was running at pretty decent level and you only drained.
That's probably what you're gonna get out of it. You won't
Yeah.
get the full 2 gallons out, because you can't get the entire amount out of that compressor. Even whenever you drain the oil out of it, you pop this valve off, you get a little bit, and that strainer, you're gonna get some out, but you're still gonna have maybe a half pint or something in that bottom of that stove. You got some over here, about maybe a liter over here in the motor cavity. So you're not gonna get it all out,
But still put the 2 gallons
but I
back
would
in?
put 2 full gallons in.
Okay.
Yeah, I'd go ahead and do it. You can't reuse POE oil
Right.
whenever you're capped it, try to cap it back off again. There will be some guys that'll tell you, well, yeah, you can just bathe that can with nitrogen and then cap it real quick and you'll be okay. I wouldn't take the chance. I just really wouldn't do it. Because really, if you get 2 gallons and you get 1.5 gallons, you think, well, probably I'm good in there, I'll be all right. Well, is a half a gallon worth it? I mean, just put it on in there. That way you don't have to worry about contaminate it. And somebody goes, well, I got a little bit left in this can 2-3 years later and I'll put it in there. But you may just put some oil in there that's full of water now. So you just did more bad than you did good. Does it make sense on the solenoids? Any questions? All right.
Should we take a 10-minute break?
Yeah, absolutely. I was about ready to say, if you guys were ready to take a break.
Yeah,
Send your text. In a meeting, kind of. It's great.
Have an egg white spinach.
Center dish was all the same.
It was in the kitchen. So, yeah, right above the cook line,
Which number?
2 ducts were disconnected, right?
Yeah.
Show me.
How's it going?
So,
Oh, yeah, it's good, yeah.
just judged about the T-bar wire that came down, and it was just caked in dust.
Yeah, World Trade Center, north.
They're like,
We have to go in there and get it
We're
figured
gonna have to
out.
have Ryan sort out.
in the morning?
yeah.
See those fires.
Yeah. But again, changing one out for another one, it's a drop-in replacement. There's no retrofit really other than those 2 coils. The 6 terminal lugs on the 5 series and 2 series terminal plate. Again, like I said, you can put this in a Y delta start or a cross-line start. You see the 100 horsepower compressor, you're gonna see actually 2 terminal plates on that compressor. There's one unique thing about the 100 horsepower compressor is you could run that on 230 volt or 460 volt with the same motor in the compressor. It's very, very versatile. I'm not really sure. I guess they were just too expensive or something. I'm not really sure why the OEMs didn't kind of go for that, but because more and more we're getting away from the 40, 50, 60 horsepower being a desired screw compressor because your scrolls are getting so big and cheap that, you know, should you get a scroll, a 60 horsepower scroll now. But again, I personally have to say, scrolls are getting big, they're getting cheap, but they don't last, they don't have the performance that a screw compressor does, they just don't, but they're cheaper.
You guys got any of these on drives, Don?
No, we don't. I've gone back and forth with the factory on these. We had guys have asked us about that, putting drives on them. You rely on the suction pressure coming back to free on cooling that motor. So if you run it down too low of a RPM, then you're going to overheat the motor.
Okay.
So we wind up having to have some liquid injection or something in there to keep that motor cool. But the factory's been very pushed back with me as far as wanting to do that or approve that. I'm not saying it can't.
Right.
But you'd always, if you ever decided you want to take that on yourself, say, hey, we can do these, we're gonna put these on drives. Just be careful, because you get down to low volume flow through this thing, your motor's gonna start getting hot. Because that flow what keeps that motor cool.
Okay.
And how would that work with the slide valve and loading and unloading?
Pardon?
How would that even work with,
You'd lock it.
yeah, I was just gonna say you'd have to lock that
Yeah.
in place or something, then just use the VFD for capacity?
Yeah.
I just didn't know if the Hitachi's done. I know Bitzer has them, and
Yeah.
but I don't know if you guys had any Hitachis.
No.
All right.
Not
You just
not
need a way to
today.
monitor motor temp, you just have to put some sensors on there,
Yeah.
so you can monitor.
Do you have like a minimum hertz?
Pardon?
What's the minimum hertz that you would do? Or do you have a
Yeah, just
issue?
have a floor on it.
I think I've got a sheet, I think you're 10 plus 10 minus percent is what they can allow. Same as on the voltage, it's 10 plus 10 minus percent. They go 50 hertz, of course, they can go down to 50 hertz, but I don't know if I really have seen a minimum on that. I'll check into that for you. Okay, section 3, we're going into the operation and maintenance now, rather than just the design of the compressor. Any other questions on what we've covered so far on design? Mostly pretty straightforward stuff, but. All right. Operating conditions on the compressor. The following conditions must be observed in order to avoid damage to the compressor. Failure due to will avoid the manufacturer's warranty. Now, we do honor any kind of warranties to bring them in. If you guys have one that failed in the warranty period, we'll bring it in. Our policy is we bring it in, we do a tear down report on it, and I've got a copy, we'll go through that a little later today. One of our tear down reports. We tear it down, photograph it as it's being torn down to find out why it failed, or what components showed wear or whatever on it. And if there's a defect in it, or if we can't determine what it is, we'll warranty it for you, but 99% of the time we can pretty much tell what happened to that compressor when we tear that thing down. And you know, running backwards or something like that, you can see that. I mean, you can see the scar pattern, which way those screws were hitting. It's, after you've done it several hundred times, you kind of get forensic on these things after a while. You kind of know from the pattern on this thing why it failed, or give a customer a good idea of what to look for. And we do that as well. If you got a customer that's got, I've had 2 or 3 compressors fail this thing, we can't figure out what's going on. Well, your last failure, we can bring it in, we can do a tear down on it, and show you what we find, and that will kind of give you an idea of maybe what to look for in that system, but what's going on. What kind of heat pattern did it have in it? Why did it, different things in it that may point a direction of looking in the system of why the compressors keep failing. And we do a pretty minimal charge on that. I think what is it now? Our teardown reports, I think, are $350, something like that, to do a complete teardown on it. So it's not that much really to do. We do oil analysis on that as well. We draw a sample out of the compressor when we get it to find out what condition the oil is in that core when it came in. So it's pretty good information if that's something you guys are ever interested in. Reverse rotation, like we talked earlier, reverse rotation is not permitted under any circumstances. It will damage the compressor, avoid the warranty. Again, compressor shutting down, when you shut it off, you'll hear it spin backwards a little bit because that is just equalizing the pressure from suction to discharge. So when you got suction pressure coming in, you're low pressure, you got high pressure on this end, you got a check valve over here, you shut the compressor off, that check valve pulls down, this discharge high pressure has to go path of least resistance, which back through that compressor. That's going to cause those screws to coast backwards. You'll hear it when it shuts off. And that's not going to hurt anything. There's a totally difference between coasting backwards and running backwards. Now, if you hear a compressor, it's usually normal to hear a compressor coast backwards for about 10 seconds, 15 seconds tops, usually. If that thing coasts for 45 seconds or a minute, your one-way check valve's leaking. It's not seating up. So it's allowing that not to equalize as quickly and just sits there. That does that for about a minute. Your one-way check valve's leaking. So you just need to get that thing, your core replaced or something like that. That's not gonna hurt anything other than allowing possibly refrigerant to migrate back through that one-way check valve down to the compressor. I've had guys before that have called me and said, well, I start this compressor up and it trips out right away from high amps. And we found out, well, after talking through it, we wind up having liquid refrigerant migrate back down and sitting in that compressor. When it starts, you got a bunch of liquid in that compressor. So you got a high torque load on that thing when it tries to start. So I've had them just, isolate it, evacuate what's in the compressor, open it back up, start it again, took right off. So that tells you right there you just had a liquid migration problem.
When I was at Carriers, we used to, if we did a screw compressor, you were supposed to put a high or low pressure switch in series with the high pressure switch. That way it'd knock it off immediately. You wouldn't run for 2 seconds.
Yeah.
And just says that if you didn't, they wouldn't warranty anything. So don't stand by it. They're like, nope.
Yeah, some manufacturers say I won't allow that for 2 seconds.
Yep, and don't even trust the CTs on that stuff to tell you phasing, because if they get swapped, if one gets swapped around, it can be fooled, and it'll run backwards. So we had that problem too. So.
Yeah. Always got to be very, very careful. Like I said, personally, like I always promote to everybody is, even doing phase rotation and all that, and kind of safeties, anytime you change the compressor, put your gauges on the compressor when you start it. Your gauges aren't going to lie to you. One's going to go down, one's going to go up. Just be sure your suction's the one that goes down. If your suction goes up, you know immediately, wrong way.
Weird. Is it abnormally loud, like when a scroll runs backwards?
No, not really.
It sounds the same.
Doesn't take very
Not
long.
for long.
They run for. They don't run long.
Not initially, put it that way.
Right.
By the time you figure out what's going on, it's too late.
Yeah, you probably got, I've got some manufacturers on a train and some other manufacturers say, you can run it for 2 seconds and you trashed the compressor, you killed it right away. You probably got, well, it varies, because I've had guys that, I know a guy on site that ran one backwards. It was probably 10 seconds he had it on there, then they trashed it. I've had a couple guys say they did it and it was like 2-3 seconds, they caught it real quick and shut it off, redid it, put it back on, and it ran fine. So you got a couple seconds. Again, I kind of got to go on the side of caution of just don't do it. But if you catch it right away, you may be okay. But if it goes 5-10 seconds, something like that, you're probably not. You may break it loose even. Starting to grind into it, and I shut it off. Okay, I got to break loose. But a week, 2 later down the road, you've already done the damage. So it's going to eventually.
How many people here have a rotation meter? 3? 4? Todd's probably got one, Scott's got
I don't
one.
have
Grayson? Todd, you don't have one?
I've always done it that way. I've never had one run backwards though.
Yeah.
Ever.
Too good.
Knock on wood, I know. I always check the pressures, but I've never had it.
It's kind of, to me, I'm kind of an old school kind of guy, but that's the fail-safe way.
Throw the main. Don't even waste
No,
any
I know.
time. You throw the main. You don't.
Yeah. Yeah, you got a guy next to a kill switch. If you're not winning, you got another guy standing there that can kill it just.
We were down in a mine. This is why I know about this, because we were down in the mine working on it. It was a mess, but at any rate,
No.
the CT said the machine was running backwards. But they had to have the panels rebuilt on it. So another company. But when they did it, they swapped CTs around, and we were, coming from the factory. We just don't have these problems. They don't ever, the CTs are always right. And so we didn't even know. There's no arrows on them. There's nothing on them. It's just 3 green pucks sitting there. So you have no way to know.
Right.
And sure shit, the thing was. So we swapped it. We swapped the leg, the phasing.
Right.
So one of them started up backwards, and we're like, "What the hell is that?" Because we'd never heard it. We're like, wow, that was weird, and it tripped off on high amps. It's like, wow, that was odd. And it was like, And then the other one. So then the next one started, and it started up, and it was normal. I was like, oh, well, that was really odd. I wonder did we not open the check, we thought we didn't open the discharge valve or something. You're like, what did we do? I'm like,
yeah.
So we go to the next machine. It did the same thing. Well, so then we stopped. We were like, okay, there's something wrong. There's something seriously wrong down here. Well, we didn't hit the switch to off, because we were so busy. And then the third one had started. I was like, oh, God damn it. And so by the time I threw the switch, it was
trash.
Save it, yes. Save it. So we lost 2 of the 3.
It makes for a bad day.
Yeah, it was like, it's confusing. And then we finally talked to engineering, service engineering, and they're like, oh, yeah, those are directional. And so then they had to go to their lab and they duplicated the problem. They're like, uh-oh.
Got a problem here.
We have a problem, yeah.
No doubt.
It's a mess. Of course, we're 5,000 feet underground, you know.
Yeah, that'd be tough.
So there's no software, so there's no way to ask anybody.
Let's see, power and control circuits, just a formula for sizing contactors. That's something we can offer as well. You know, if you guys ever get compressors from us, if you need contactors as well, you know, try to get try to make ourselves kind of a one-stop shop when you get some of this stuff. You know, do you need cord dryers, you need contactors, you need anything else, just give us a shout. We'll try to get you what you need. We like to see, and this doesn't happen on everything, I know, but we like to see all control circuits designed to have a manual reset instead of an automatic reset. You know, if you've got a problem, something trips off, just kind of hate to see it, just time out, cycle back on, and go again. If it's tripped off, usually we've got a problem. I know as a service guy, and I've been there before, you don't want that call at night where, gosh, why do I have to go back up that building again, tripped off again. It'll up and go, you know, it'll reset itself and it'll go again in a minute, it'll just let go, you know. But, you know, really, if it tripped off, you really need to get up there and find out why it tripped. That's why the manual reset is, makes you get up there, makes you find out what's going on. So that's what we recommend. Suction and discharge pressure. In a pump down cycle, that's when the liquid refrigerant's closed and liquid line closed, remove the refrigerant from the evaporator to the condenser. Not permitted where pump down is allowed to suction pressure to drop below 7 psi. And I know this is a very low, in my opinion. Hitachi puts in kind of some extreme numbers here. Low suction is 7. If you're in a pump down cycle, normally, you know, 40 psi is definitely low enough. You shouldn't be running 40 psi in the standard system anyway. If you get down below that, you're either low on charge or something else is going on as well. So definitely not below 7, but I'd bump that up a little bit as far as seeing a pump down shut off.
So, quick question there, Don.
Yep.
Got a lot of guys that tell me that you can't pump a screw down for a reason. So,
Okay.
I want to pull the refrigerant out of it, put it in pump it down to, they don't want it running in a vacuum at all. Is that true?
I wouldn't run it into a vacuum.
Yeah.
But I would do, if I was just pumping it down to get everything out of there,
Just to change the oil, whatever.
I'd pump it down to, you know, single digits and then shut it down. That way you can recover with just what little bit what's left in there.
Yeah. So don't run it into a vacuum.
Don't run into a vacuum. You don't get good oiling. You could start building friction. It's something that's marginal where you're starting to get a little wear in that compressor already. If you do that, you could escalate that and, you know, cause more damage.
Okay.
So that's my opinion.
All right.
I'd slow down and just, I'm not saying it can't do it. Okay.
No, I know it can.
But, yeah.
There's different opinions.
There are some things that I have to tell you.
I know.
Some things that I tell you, and I usually try to share my opinion on what I think is realistic and what the factory says to do. But I'm obligated to tell you certain things of, you know, don't do this, don't do that. Even though sometimes, like I said, kind of like this says, it can do that, even though it's not really recommended to do that. I'm not saying that you're gonna tear it up every time you do that. But on that situation, like I explained, possibly, if we have some wear in the compressor or starting to make a little contact, you don't want this thing to run down where it's not getting oil for any period of time if possible. If you got a nice clean compressor running really good, you probably could do that without an issue. So at your own discretion. Disclaimer.
Well, they're gonna.
Say what? Go ahead. That's
Oh, I'm
open
just
forum
thinking
here.
if you pump it down like that and you do work on it, when you go to start it up, a lot of the systems have a time delay on startup before they open the cylinder liquid line valve. So a lot of times they go into a vacuum when they go to start, if you do something like that.
That's why you
What I've
don't.
been doing is transferring refrigerant over before I do it.
Yeah.
I thought you should, open that liquid line a little bit or something. Put something in there somehow.
Yeah, because the mammoth is usually like 25 seconds.
Yeah,
Even
no
open
one-
the liquid lines.
Yeah, I never understood that.
I don't either.
Liquid line should open immediately as soon as that compressor starts.
I don't know why they do it.
Contactor kicks in, your liquid line should be open immediately at the same time.
Yeah.
Why they do that, I do not know.
What are you
Unless they
saying?
feel like they're trying to
You're saying
vacuum
a
the line.
delay
or something.
between liquid line valve opening and
Startup.
Compressor starts, liquid valve.
All mammoth units do it.
And you start up, compressor's running for 15, 20,
Yep.
25 seconds before the liquid line even opens up. Not a good idea. I mean,
They're trying to prevent some kind of liquid slug or something.
could be.
Yes.
If you got a slug
Makes sense.
coming in there because of that, you got other issues. But, you know, I'm sure there's a lot of engineers who argue with me on that point, so, again, I'm gonna give you a lot of my opinions today, so you kinda gotta take it for what it's worth.
And that's an adjustable time delay on that thing anyhow. I always make it like 7 seconds.
Shorten it up as much as you can. I agree.
Let it run.
The high discharge pressure, pressure should never exceed 370 PSI. This is kind of based on R22. I always recommend for your high pressure discharge cutout, put it about 360. That's a good safe spot to have your high discharge pressure cutout at 360. Never exceed 370.
Is that the same for 407C?
It's about the same, you can run it the same. I have to go back and look at my charts. It seemed like it did adjust a little bit, but I'm still just
Pretty
with that
close.
safe pressure.
Sounds close.
Yeah. Discharge temperature, let's see, I think that's the next one. I'll get that, yeah. Okay, other operational safeties, electrical, applied safeties. Again, we like to have all this at manual resets if possible. Phase reversal, voltage protection, phase loss, phase imbalance. Your phase imbalance, you don't like to see more than 3% imbalance on your phases, if you can. Phase loss, single phasing, of course, you know, if you lose a phase, you're gonna short that motor out in just about a heartbeat, so you definitely want that safety on there if possible. Your voltage protection, you like to have 10 plus 10 minus is our allowable range for the voltage, so you can get down as low as a 460 volt compressor, as low as 414 or as high as 506. We don't want to try to keep it in that parameter if possible. Overload protection, based on the rated load amps, and you'll see the rated load amps will be on the compressor, but you won't see the full load like we talked about earlier. Full load, you want to look on the nameplate of the unit. Motor over temp protection, 239 degrees. Now there's a PTC thermistors are embedded in the motor. There's one in each phase of the motor. And we've got a Cream-On thermal motor protection module you can connect these sensors to so that it monitors that resistance to that temperature in that motor to trip that out. And you want to be able to check those every now and then if you're servicing them. On those PTC thermistors, you'll have, like I said, that little 4-bolt box. You can't see it on this one. It's about over here on the motor side. It's about right here. There's a 4-bolt or about a 4 by 4 inch box. Take that box off. There's 4 terminals on there. They're marked C, S1, S2, and S3 common. And then your 3 sensors. If you want to check those out to see if they're working properly, you take all the wires off of them. You ohm out between C, S1, C, and S2, C, and S3. You should get between 900 to 2,500 ohms at any given temperature. And it could be in the same compressor. You could have one at 950 and another one at 2,200. That's okay. As long as you're within that parameter, you're all right. Now, if it trips out, it doesn't slowly go up. So it go, well, it's hot, I want to get a high reading. If it's cool, it's going to get a lower reading. It's not, because when it hits a certain temperature, those PTC resistance shoots up. It spikes very quickly, about 14,000 ohms, and trips out. Now your resistance got to be below 3,500 before that module can reset. So if you try to, okay, I think it's cool enough, I'm resetting the power on this thing, but my module isn't resetting. Ohm out your sensors, be sure they're below 3,500. If they are, then we got another problem with the module's, you know, gone bad or something like that. Discharge gas temperature, like we said on the pressure, about 360 PSI. On the temperature, safety cutout, no higher than 248. I usually recommend about 240, 245 for your high discharge temperature cutout. Be sure you don't really let it go above that. I had another job out in Detroit. I went to go see a guy who was wanting to change out some controls and on some Hitachi compressors. They had all kinds of troubles with them failing. So I went out there to see what he had, making some notes and stuff, and I walked over and saw the high diff. He had mechanicals on a Mammoth unit. These were pressure controls. He had a high discharge temperature mounted right there next to the line, and it was set to 350. I asked the guy, well, why is this thing set at 350? He said, because that's where it'll stay on. Jesus. You know, you don't want to be up there, well, you know, it keeps tripping, that's why I just turn it up a little bit more. Okay, it stays on. Yeah, it stays on. Okay, I can go home now. You don't wanna just keep turning it up till it stays on. You know, if you keep tripping its temperature, something's wrong, we gotta correct it. This guy could have fried an egg on that compressor. That's why they were killing compressors. So sometimes it's just those little mistakes, and that's a big mistake. But mistakes like that you don't wanna make, you know. Make sure you do quality work, and, you know, even though it may be more work, you wanna get out of there for the weekend or whatever. Sometimes jobs are like that.
Even 248's hot. That's
It
hot as
is.
piss.
That's hot.
Yeah. We're used to
If it trips out, we got a problem.
yeah, we're used to like 160, 170.
Exactly.
248 degrees.
Rare area above 200.
Yeah.
You know, usually it's 170 to 190.
Run the sprinkler on there.
If it usually goes high, sometimes it's usually something pretty simple. You know, we got, you know, the condenser fan that's getting dirty, or condenser's getting dirty, or a fan quit, or belt slipping, or something like that. Maybe something real easy to fix.
No lessons.
On the Hitachi compressors, you normally won't see liquid injections in the compressors. Now, you can do that. And I don't have a cut sheet in here, but I've got a cut sheet. You can show you how to set that up if you need to. But only if you got where they've designed this on a unit that actually is habitually running hot. They've, you know, undersized the thing, and, you know, you don't have enough capacity and this thing's just running too hot. They don't want to do much else different. You can put liquid injection on them, but normally, a normal operation, normal design, you should never have to do that. That's why there's a note in here about, goes above 248, liquid injection cooling, extend the discharge gas limit to 266. Return, looking for Hitachi published details on liquid injection cooling for details. And again, if you guys ever come across that, you need it, just let me know. I'll email you the cut sheet on how to do that. But theoretically, you should never really have to do that, unless something just wasn't sized right in the unit. Low pressure protection, again, with 7 PSI cutout, and again, if you have a pump down, I would recommend, you know, if R22, I'd recommend about 40 PSI for your pump down shut off. And if you got unsafe suction, I'd put that probably about 20 PSI. Unsafe and low suction and unsafe suction is two different things. Low suction means on some controllers, it gets to a certain suction reading, it's going to try to unload that compressor to get that pressure back up. You know, it's going to sit there. If it stays too low, then it'll trip it out. Now, unsafe suction means if it hits that certain point, it's not going to let it keep going or unload. It's going to trip it out anyway. So I put my pump down about 40 or so, and then my unsafe at about 20. You should be safe and not get into those single digits when you really don't need to have to do that. Because if you go to 7 PSI and it's not going to trip out to 7 PSI, this thing sits at 20 PSI and it just keeps running, you're going to freeze something up. You're going to have issues. So again, one of my realistically speaking things is don't let it bump that number up a little bit. High pressure protection, 370 again, recommended. I would put it about 360 for your high pressure cutout. Starting and stop limitations. The compressor does not, we don't want anti-cycling on this compressor, so you do not want this thing to start more than 6 times an hour. That's once every 10 minutes. If it cycles more than that, you can get that motor hot and you can burn the motor up. So we want to either have a anti-cycle delay on it, a minimum runtime on it, something like that, to try to prevent any short cycling on this compressor and kill it. Sound like you've had, it looks like maybe you've been exposed to that?
Oh, yeah, no, I'm just thinking
Yeah,
about it.
yeah, okay, yeah. So,
Not too long.
once every 10 minutes, like I said, not more than 6 times an hour for your short cycle on the compressor. Discharge gas valve requirements, check valve requirement, now you do need that. So on the discharge line, going out the discharge into the compressor at the end of the oil separator. Normally, you know, put it as close as you can, really. But if it's within, you know, you want 20 feet down the line. If you got within, you know, 3 or 4 feet, you're good. But to have it fairly close to the end of that compressor. That way you reduce that backspin, that equalizing of the compressor as well whenever it shuts down. The closer it is to the end of the compressor. And your temperature probes, put those as close to the end of the compressor as well. That way you get a pretty accurate reading. Try not to put those on down the line somewhere. Get them as close to the compressor as you can. That way you get as close to you can the reading in that compressor for the discharge pressure or the suction, either or temperature, I should say. Suction gas superheat. Hitachi allowable is 9 to 27 degrees, which is a pretty big range. It can range a little bit on you where you're from, geographically, your elevation, all that kind of stuff. But normally, rule of thumb on the Hitachis for an R22, about 12 to 15 degrees suction superheat's a good point to be at. You get down in the single digits, you could be getting liquid in that compressor, and you get up in the 20s, you could be starving the compressor. It's going to start getting hot on you because you're not getting enough refrigerant to it. If those start getting kind of out of whack, just do a little tweaking on your TXV or however you're set up to see if we can get that up or down, whichever way you need to go with it. Discharge gas superheats, minimum 54 degrees. Oil requirements, as we talked earlier, oil visible in the side glass under all stable operating conditions. Again, realistically, there is agitation, so if that drops out, comes back, drops out, comes back, that's okay, as long as it doesn't drop out and stay out. If it stays out more than a minute, you need to add a little bit of oil to it. And I would check it under full load if possible, trying to find out the lowest point on this compressor, try to get to full load, that way you'll get your lowest point in that oil side glass. Again, there's no oil pump in the compressor, so you need to maintain a 70 psi differential to get adequate oiling through the compressor. So be sure to just check your pressures, be sure you get 70 difference between the two, you're good to go. Crankcase heater, you always want to maintain your crankcase heater at minimum 11 degrees higher than the other components in the system. Make sure your crankcase heater is working, and it also helps keep the refrigerant from kind of embedded in the oil, impregnated, so it can't boil off. So be sure that crankcase heater works well. If you get a replacement compressor, it's always a good idea to get a crankcase heater. If the one there is working, just be sure it comes out. It slides in this, one of the suction heater slides in the hole right here. But they normally put thermal paste on them, and that sets up like concrete. And that thermal paste is so if you got any inaccuracies in the casing, a little dip or something that fills that void, so you get a good contact through there. But you might not be able to get that crankcase heater out of it. You might got to break it out to get it out. So just be sure if you don't want to get a crankcase heater, you can pull the old one out. I've had a lot of guys buy them, say they didn't want it, and then 2-3 days later they want me next day or my crankcase heater. I couldn't get it out. So just, like I said, just be sure you can get it out. Protective devices. Always also about the oil strainer. If we don't, one way we can check this thing to find out if it's got a restriction across it without actually pulling it out to look at it. Like I said, in the oil sump is always exposed to discharge pressure. This angle valve is right in line with the internal part of the strainer. So the strainer goes in here just like this, and your valve gets the pressure inside here. So what you can do is you can take a pressure reading right here on this angle valve, compare it to your discharge pressure. It should be almost identical. You're taking a pressure reading inside of it, and your discharge pressure is on the outside of it. If you're within a pound or two, you're okay. But if you're more than equal or more than 5 psi difference between those two readings, you got a pretty heavy restriction, so you need to drain the oil out and get the strainer out and clean it off, unless you got a bunch of debris. You could do the same thing with your suction strainer over here if you've had a suspect that maybe I'm getting plugged up over here. There's 2 ports on this casing right here that are kind of cut out right now. They're common to suction pressure. You can take a pressure reading on that one of those ports. Normally you got a pressure transducer on there for your controller, and you got another one for service hookup. And then take a pressure reading right here, and then if you got it on your suction line, take a pressure reading. Just compare the two. That's on the inside and the outside of that strainer. See what kind of differential we got. Same thing, you should be right at identical. If you're more than 5 psi difference, that's enough to tell you I got to get that out of there. I do have a restriction there. Okay? Protective devices, the motor protector. Like we talked before about the PTC sensors, we do offer a motor protection module. The one we currently have, we used to use the Texas Instruments motor protection module. Those were discontinued several years back. Currently we're using Crewan. It's a German-made motor protection module. It looks identical. It really is the same thing, but it's just got a different manufacturer's name on it. Very simple. It's a dual voltage, 120 or 208 volt as well, so you can use different voltages on it. Very adaptable. We do have some information in here. We also have a Texas Instrument module called a 2 ACE module. And that's for some controllers to get a amp draw reading as well as motor protection, thermal motor protection off of it. That was discontinued several years back as well, and we started putting together a package for that to be able to get the same thing off of it, which would be just a CT current transducer and then the 04 module, the pre-1 module as well, to do that. And I've got another box because that'll give you all your readouts for the 2 ACE module, but the 2 ACE module also had 8 other trip settings on it. And we do have another box we can get and put together which you can get exactly all that same stuff, even though it's pretty expensive to do that. But we can still offer that in case that's something you guys want to do. Okay, oil heater. Oil heater is a 120 volt, 200 watt crankcase insertion heater. If you ever do break that off, you know, you're working on this crankcase heater and you wind up, yank that thing, you bust it off inside here, just get a 1/2 inch drill bit, 1/2 inch mason bit, and you can drill it out. And the casing just goes in, you won't drill a hole into the sump or nothing like that. It'll bottom out, and you'll know when you're bottomed out. But you can drill that hole out so you can get your new heater all the way in there. Because those crankcase heaters, if you don't have something making contact with that heater, if I put the heater on the table here and put power to it, it's going to turn cherry red in just a few seconds. It's going to pop and blow out. So you don't want any hot spots like that to happen where I don't have complete insertion in there and coverage and cause your heater to blow out again on you. So if it does break off, try to drill it out so you can get your other heater in there all the way. And I do recommend putting thermal paste on them. It's just, it does, in case there are any dips or imperfections in that casing, that will fill up that void and make good contact with that heater, and won't make any hot spots as well. Continuous capacity control. Change the oil pressure, the oil cylinder, 3 solenoids, they're all 120 volts coils. The coils are exactly the same, the valves are exactly the same on all 3. Again, just the directional arrows on how you mount those valves. The little valves are solder sealed, so you can't take them apart and examine. Like, I think one's leaking, can I take it apart? You know, some of the old valves you could take apart, take the top off of it, and you get the stem and the spring, and you could get it freed up maybe, and put it back together and put it back on. These are solder sealed, so you can't do that. You basically have to just change the valve out if you think that's what's going on. Those 2 little cap tubes on the front of the compressor, you know, we looked at those cap tubes earlier. One way you can troubleshoot one of these things, if you think one of these things are leaking, is when you energize the load solenoid, you grab the load cap tube, which there's 2 on it. One comes out of the front, curls around, stays in the front. The other one comes out of the front, curls around, goes up over the top of the compressor into the back of the compressor. The one that goes up over the top of the compressor, that's your load capillary tube. When you energize your load solenoid, you can grab that and you can feel it starting to get hot because it's flowing hot oil through it. The other one's not. You should be able to feel the temperature difference between the 2. If you're trying to check these things out without having to just change them, you can grab hold of both those cap tubes when you energize that. If they both get hot equally, well, the one you're not energizing, that one's the one that's leaking by. And you can't check your rapid load because it goes to an internal journal. There's nothing external to check. But that's just one way you can check the normal unload or normal load to see if it is actually working right, or is it actually flowing hot oil through it when it's not energized. If it is, then that's leaking. You just have to pop it off and put a new one on there. Okay. Reverse rotation, check valve must be installed on the discharge piping to prevent reverse rotation during shutdown of the compressor. Electrical phase protection required to prevent reverse rotation at startup on the monitoring of the lost phase. Now, it doesn't stop it from returning or doing a reverse rotation, but it just coasts down. It doesn't run backwards. It's not a full RPM run. Drawn against that thing, it's winding down and then equalizing pressure back so it doesn't hurt the compressor whatsoever. Discharge temperature protection. Manual resets, what we always recommend for your discharge temperature protection. Must be provided at the limit operations to the compressor when the discharge temperature exceeds 240. It says 248 in here, but I put it about 240. I really wouldn't go over 245. Like I said before, it says in here the discharge gas temperature sensor should be as close as you can to the end of that compressor. They say in here 9 9 7/8 inches from the end of the compressor. I don't know how 7/8, but 10 inches or so, you know, foot past that compressor, or as close as you can. You can have it right next to it if you want. Gets a good and insulated. You know, I went to one here just the other day where they had the discharge line temperature sensor on it and just clamped it on there, and it was there. Insulate the thing, because you know this was outside on a roof, and you know you're getting exposed by atmosphere temperature. You know, it's cold winds blowing like crazy and it's coming in there, that thing, that's going to affect that. So wrap that thing in insulation so you get a good reading on it. Here's a cutout or some tech information on the module, the standard module for the compressor. You can see how it comes out. You got M1 and M2 on here, which is your control circuit. It should be normally open. You put power to it, it closes normally closed. So if you ever want to check your module, be sure you got power to it. Be sure if you want to see if your circuit's closed, because if you're checking it with power off, turned off, it's going to be open. M1, M2 should always be closed unless it's tripped. You know, if you're running this thing's off, like I power to my module, I check it and it's open, your module's tripped. And the only way, all you gotta do is reset the power to it, it should reset it, and you should be up and going again. But you need to kind of figure out why it did that. On the module, you got S1, S2, and S3 in common. Count down this little plate on the side of the compressor. You can see how it goes down, and then it's just embedded in the motor windings. You can see how the resistance scale goes. It's down here real low, then when it hits certain temperatures, it just spikes very quickly. So it's not something that heats up, your resistance doesn't slowly go up. It's going to stay at a certain point until it gets a certain temperature, then it spikes. So you can really check that when it's running, when it's warm, when it's cold, it doesn't matter. Your resistance should be pretty close to the same, unless the thing's tripped on you. This is that 2-ace module I was talking about. We do still have a couple of these left, but we are putting together the package because we know these things are, you know, there are no more of them. So in case you come across them in the field, here's some information on them. Here's how they're set up in the wiring. You've got set at 120 and 240 volts. The 2-ace modules are 24 volts. So you probably have a little transformer in there as well to power that up. You get your sensors for your module and your motor. You also have an amp draw reading that can come off of it. It's got 3 little holes on top of it, which your power leads go through. It gives an amp draw reading for your controller. Plus it has, yeah, there are 8 different other protections. I got a sheet in here to show you all of them. There's little dip switches on the back of it because it has a must-trip amp setting on it. If you flip the thing over on the back, there's a bunch of little dip switches that are cumulative as far as how many amps you set this for. And there's a little bitty window on there. It's got LED light that will flash MHA, and whatever your trip setting is. It says 200 amps on its trip at. It'll flash, during normal operation, it'll flash MHA 200. Now, if that's, you see, look back there, the compressor's off, got power to it, and it's flashing that. It hasn't tripped, it's where it should be. Now, if you got a letter 1 through 5, or a number 1 through 5 on there, which is a solid number, it's tripped. And that number tells you why it tripped. We got a number, this sheet tells you why it tripped. So if I say, I look back here and it's got a 5, well, it tripped on over temperature. And same thing on this one, you should interrupt the power to it, to reset it, should be up and going again. But this 2-ace module being discontinued, I mean, we can get a CT sensor, we can get a motor protection module to do exactly the same thing, except we don't have all these other safeties. Now, for somebody that wants that other safeties as well, we do have another box we can get and put together, but the whole thing package is going to be $1,500 or something like that. It's not cheap. But if you want these other safeties to be in there, I mean, we can accommodate that. That's something we currently are putting together. Again, HA, hold amps, but it says it'll be MHA, must hold amps, is what it'll flash. It goes from 25 up to 225 amps. So you can put these on several different kind of compressors. An amp draw reading anywhere from 25 up to 225 to trip out. Okay? And electrical phasing for the proper compressor rotation. Again, we've gone over this a couple times already. You know, use your rotation meter if you've got it. Use a set of gauges, definitely I do that even if I had a rotation meter, I still use a set of gauges. The compressor can be used for Y delta start or cross-line start. If it's cross-line start, you've got cross-line bars, as it, like up there in figure 106.2, little bars going across it. You only have 3 leads coming to the compressor, power leads coming down there. If you've got 6 leads coming down to that compressor, then you're a Y delta start. Whenever you're ohming out the compressor, you're doing troubleshooting this compressor for a shorted motor. You can see at the base of the motor, you got U, V, W, Z, X, Y. Now whenever you want to ohm this motor out to check to see if I got a bad motor out, you take all the power leads off the motor. You don't want to leave your power leads on the motor when you're trying to ohm a motor out because you got all that wire going to the contactor that could be influencing your ohm reading. So you take it all off. If you've got cross-line bars on it, you take those bars off too. And you don't go right across from each other. Whenever you ohm these motors out, phase 1 is U and X. It's kind of diagonal to each other. Phase 2 is V and Y. Phase 3 is WZ. That's where you'll get your ohm reading. They're all diagonal to each other. Sounds weird, but that's diagonal to each other. And I got another drawing in here. I'll show you a drawing of the windings and how they all connect together. 460 volt motor, you'll normally get between 0.3 to 0.9 ohms. A 230 volt motor, you'll get about 0.1, 0.2 ohms. Anytime you ohm the motor out, ohm out between UX, VY, and WZ, and you'll get those readings. But don't stop there. Then you'll want to ohm out between U and Z and U and Y. That's ohming out between phases. Because you may not have a short to the casing, but you could have a phase-to-phase short. You should have open line between any of your phases. So it should be OL, you shouldn't have any reading at all. And then you can meg ohm from each one of the terminals to the casing. You can ohm out or you can meg ohm. Meg ohm just to the casing. Don't meg ohm when you're going phase to phase. Don't meg ohm with doing that. Just to the casing.
So 1.4 to 1.9?
1.3 to 1.9 will be a 460 volt motor. 0.1, 0.2 will be a 230 volt motor. It's what you normally will get when you're ohming out the motor. Then once you confirm that's all good, you can put it all back together. But again, take all your wires off so there's nothing influencing your ohm reading whenever you try to take those ohm readings.
Is there an average mega ohm reading, or is it just based on just consistency over time?
It may vary a little bit on you, but we like to see at least 100 or greater on your mega ohm reading. I have had some service calls in the back or before where guys have called and said, hey, I'm checking this motor out, doing a PM on it, and I've got a low meg ohm on this thing. Everything seems to be running fine, but I'm getting a really low meg ohm reading on it. And what we found more than once, if you're not careful, is if you have moisture in the oil, that can cause a low meg ohm reading. You're getting something conductive in that oil. I've had guys that, you know, everything seemed to be okay. Or do oil analysis lately? No, we haven't done that for quite a while. So you can either do oil analysis or just change the oil on it. Change the oil on it, and meg ohm reading came up. So he had moisture in the oil.
How low were you talking that they were reading?
25, 30.
Oh, wow.
You know, they were getting a little scared. That's why they were calling me. Going, it's pretty low. You know, it's running, but you know, I'm getting this weird reading. So usually, unless the motor could start to be going out on you, but usually if it's getting that low, the motor's going to go up pretty quick. So a lot of times it can be something like that, where it's just something conductive in the oil that's causing that to be able to bleed a little resistance to that case. It's not shorting it. It's not that extensive yet, but it's something you want to get corrected. Oil specifications and maintenance. I know we talked quite a bit about oil already today, about maintaining the oil level in the sight glass, impurity in the refrigerant cycle. Want to keep it as clean as possible. I've got a sample of I push oil analysis because it's really a really good tool. A lot of people do it, and we offer it, but I don't really care if you use us or anybody else as long as you're doing it. It's a really good tool for you and your service group. A lot of times you can catch stuff going on in the compressor before it actually has killed that compressor and make some corrective action to try to reverse it and get some more life out of this thing. Our oil analysis breaks down about 23 different elements. You get the viscosity, the acid, the iron, the copper, I mean, several different things. I got a copy we'll show you here in a little bit. To get a good reading on it, I mean, your field acid test is okay, but that's all it gives you. And you get a little color and it gives you a basic idea, but really drawing the sample off, send it to the lab, get a good breakdown on it, that's the way to do it. And it gives you a good trend line then. Now, if you know, well, it's pretty good this year, okay, next year, does it get a little worse or does it stay about the same, or where does it go? It gives you a baseline to go. I'd recommend doing it annually. If you're in a good condition where you need to change the oil because of bad contamination in the oil, change the oil, then in 6 months, do it again. If it comes back clean, then go back to your year. If you do it in 6 months and it's still not very good, they need another oil change on this thing, do it again, then do it another 6 months. Keep doing that until you know we get a good clean reading, then go back to annually, and then you're good to go unless something else throws you a red flag in between. You know, if you're doing an oil change on a compressor and a week you walk back and that oil's turning really dark in that sight glass or something like that, that's a red flag. I mean, you don't really hardly even need to take a sample. You know that you need to do something, get that oil out of there. Something's not right.
Are you gonna talk about evacuation on that too? Because when you evacuate these compressors, I believe it's, I haven't done it in a while, but it's rapid unload, needs to be energized. One of them's gotta be energizing in order to get a full vacuum on it.
The only reason you would the only thing you don't get if you do that is you're not evacuating the cylinder. You should be able to get a complete vacuum on it, except for the cylinder. But if you want to get a complete vacuum on the compressor and the cylinder, you need to energize one of those solenoids, and your rapid unload is your best one because it's not restricted to the little cap tube.
Yeah. Well, if you do a slip ring, change out, you want to get everything out of there. That's gonna be full of air.
If you're doing a slip ring, definitely, because you can take the pressure out of the compressor, get it all out. Okay, I'm ready to pop this thing open. I take the plate off this back and pop that piston cylinder open, and bam, you got oil popping out on you. That's because that cylinder is sealed. And you're not going to get it out of there unless you energize something that's like the solenoid that's going to get that pressure out of there.
I mean, and afterwards too, because you don't want to lose any moisture, just sitting in that little pocket.
Yeah. Yeah, definitely. That's a good idea. Definitely. Moisture in the system. If you're doing oil analysis, normally with our POE synthetic oil, Hitachi compressors anyway, anything below 200 parts per million on moisture is normal. I wouldn't really throw a red flag if you're below 200 parts per million. And I think it's 300 is, no, it's higher. I think, yeah, it's about 300, I think, that we would consider it high, that you really gotta do something. What we normally recommend is if I've got, say, 225 or 230 on my moisture, it's above what we normally would like to see it. But rather than say, oh, you need to pull this thing out and change the oil, I probably recommend doing your dryer course, things like that, see if you can get that system dried up without the expense of doing a complete oil change. If not, then you still gotta do the oil change. Or depending on how thorough, or if you haven't changed it in a long time, it may be a good idea to go ahead and do the oil change. But if it's just marginal, there are other steps you can take without actually, draining all the oil out, doing a complete service on the thing, that you might be able to get it dried back up. Non-condensable gases, like nitrogen, that type of thing, we want to be sure not to exceed 2% in the entire circuit. Refrigerant oil characteristics, again, we talked about that quite a bit, about very hygroscopic. Viscosity on the SW220 is right at 220, that's your viscosity level on that. I talked a little earlier about some of the food shengs, they run a 300 or 320 in a lot of those, but if you go to a different refrigerant, you can't run that thick of oil on like 407. You got to drop that down. I've talked to the factory several times on that, and our 220 will work fine. They have another oil of their own. I think it's a 120 that they recommend as well for 407. But we've talked about them, and they came to our facility about here a while back, and they said that the SW220 will work just as well, just like they do on the Hitachi. But when you get over 300, it's just you won't get a good return on your oil with that 407, so you can't have that thick oil in there for that, just to be on the safe side. Oil charging quantities. Now this shows a shipping charge. It's a little bit different, a little bit lower than what your actual service charge of the compressor is. Like the 5 and 6, it shows 6 liters. which that's about 1.5 gallons. Actually, the 5 and 6 have 7.6 liters, and the 4002 and 4005 is just a little bit under that, but still it's just right at 2 gallons, just a little bit under. But I recommend using the full 2 gallons when you do an oil change. Okay, any questions on any of that stuff? We're on to section 4. Service information. And some of the stuff we've kind of talked about, like I said this morning, I was kind of jumping around a little bit, but we talked about some. This is a good diagram of the oil level. You like seeing the compressor. It's good as long as it's in that compressor during normal operation. If it takes off and leaves, we need to do some corrective action. And here they say it must not exceed 30 seconds. I usually put it kind of rule of thumb because that agitation effect does happen in the field. So it's more like 45 seconds to a minute it's gone, then I'd be more concerned about it. I need to add oil to it. If it comes back and within 30 seconds, you're okay. You'll be all right. Operating at a minimum load. If the oil level returns within 1 minute, this indicates the possibility of oil trapped in the system. Accumulator, piping, those are things to look at. Changes should be made in the system designed to reinsure the return of the oil to the compressor. The oil does not return within a minute, and you need to add more oil. Preventive maintenance. This is just kind of a cut sheet. This is one of the sheets that comes with our oil analysis, kind of gives you an idea of oil sampling procedure. If you're going to do what I recommend, if you've got a compressor, you know it's got bad oil, you get an oil change kit. The oil kit comes with 2 gallons of oil, the gasket and O-ring for your oil valve plate to take the strainer out, and an oil analysis sample bottle comes with it. What I recommend is whenever you do the oil change, take the strainer out, clean it, all that, do all that whole procedure. But get some runtime on that system then before you draw that sample. Be sure we get a good mixture on what's up in the circuit, gets back down in the compressor, we get a good blend on it. So we get a good true reading of what's in the system, and don't do it too soon. Otherwise, you might get too much new oil in that sample and kind of give you a false reading of actually what's there. So I give it between, it says minimum 72 hours, but I give it 40 to 70 hours, something like that. Unless something throws your red flag in between. Like I said, if we get a dark color in the oil or something like that that throws your red flag, you need to get it out of there anyway. But if nothing happens and it seems okay, it gets 40 hours, 60 hours, 80 hours, something like that on it. Make sure we got a good blend on the system. Then draw your sample, send it off to our lab. Usually it's about a week turnaround time to get your sample back. And we give you a complete back-down report of it. And then we'll know, hey, do I need to do more service, or hey, I'm good to go. Now we can mark this down and do it again next year unless something else comes up in between. And the factory provides this. I always stick this in the manuals. It's a good color chart. Just kind of like, well, if I don't want to sample it, well, how dark is it? It's dark. Well, how dark is it? Kind of gives you an idea of what's okay, what's kind of cautious, and what's you need to get it out of there. Because the oil itself is pretty clear. Maybe a little, depending on how you're looking at it, that does have a little bit of an amber color to it, but not too much. So, if you get a little bit of a tint there, it's not that big of a deal, but as it starts progressing, you can really kind of see a color in there, then that's starting to throw you kind of a red flag. Then when it starts getting kind of a brown or a black, then that's really no, it needs to come out as soon as possible. Here's just a few cut sheets of the old, this is SR30 oil change kit. Let's see. Shows you what's in the kit. Like I said, 2 gallons of oil, the oil analysis kit, and then the gasket and O-ring for your oil valve plate. I always do recommend anytime you change the oil is pull the strainer out, inspect that strainer. If you got the oil out, you might as well take another 5 minutes to pull the strainer out too, rather than just pumping the oil out and pumping the oil back in. Because there's really no way to know, is that strainer restricted? Does it look like that? I mean, if it is, we got other issues. You can't just pump another 2 gallons of that expensive oil in there, and we've still got issues going on. So it's always a good idea to definitely do that. More specs on the SW220 HT oil. The oil change kit showed a SR30 POE oil. Again, that is the original oil that came in the Hitachi compressors several years back. And when they went to the 5 Series has the SW220. And currently, that's all we use is the SW220. We don't offer the SR30 anymore. They still make it, but 4 or 5 years ago, the price hike on it went through the roof, and we thought, why are we buying that when this is really the same oil? We get it stateside, and it's just as good, if not better, because you can use it on 3 different refrigerants. Viscosity's almost identical. You can even blend the two together, and you won't have any detrimental effects. The viscosity is almost identical. The only difference you would have, or not really detrimental, but the SW220 HT, the HT is an acid scavenger. So you put that, if you blend that with the SR30, the only thing would be you dilute that acid scavenger a little bit, because what you have in the system doesn't have it in it. But it won't really hurt anything.
So your oil, SW220 has acids, like an acid scavenger already mixed in?
Yes, it's part of the blend. We like that because that also helps, since we do have trouble with POE oil and copper plating because of acid, that kind of thing. It's not going to prevent it, but it will help in trying to keep that under control. If you do get a little bit of acid in there or something, to try to grab a hold of that and keep it low so you won't have that copper plating problem. I'm not going to guarantee you never have it with the SW220, but it will help. The moisture content can affect several different things: reduce capacity, affecting performance, potentially corrode, limit compressor life, cause copper plating, leading to elevated compressor wear, reduce internal clearances, resulting in the elevation of operating temperatures. Because the backside, you get enough plating in there. I don't think I've really seen this as why the compressor failed, but if you have enough plating on the screws, on the backside of the screws of the discharge casings, a very high tolerance. It's 4,000 to 7,000 clearance. So you don't have to take much to start closing that up. And in between the screws, like I said, it's married sets. So to get that compression, you got to have a real tight tolerance in there. You get copper plating on that, it's going to tighten that up even more and affect your capacity. Okay, I think we over about all that other stuff. Here's another cut sheet just showing the SW220 kit, same as the SR30, but just thought I'd throw this in there. I haven't modified this for a while, so I used to talk about both of them. But again, anytime you do an oil change, be sure to get your pressure down inside the compressor as much as you can. Realistically, if you can't isolate the compressor and draw the pressure out of the compressor before you draw the sample or draw the oil out to do an oil change, to draw a sample, at least shut the compressor off. That'll equalize the compressor and drop at least the pressure down here in the sump from 190, 200, 225 psi down to about 70 or 80. So then you can crack that open and get the oil come out without it blowing by and foaming up real bad. You still may have to do it really slowly, but it'll be much easier. You get it during operation when you got full discharge pressure in that sump, it's almost impossible. It just blasts right past it. Handling of the jumbo oil, same handling procedures. We're going over that, how to handle that oil, compressor oil replacement procedure. This is a procedure that was put together quite a while back. It's very detailed, and one of those ones I think some engineer put together on the whiteboard one day. You got a whole page of how to drain the oil out of the thing. But just isolate your compressor, get your pressure down. Pump the oil out of it. If you get it down to single digits, it'll come right out of there. You put a hose on that thing, it'll pump right out. You put a vacuum on it if you don't want to pump it. To get a vacuum on it, that'll help draw it. Another trick too, if you're doing an oil change, not on the 40, but the 50 and 60, this is the 40 horsepower here. This one's got one flange over here where your discharge line connects to. This is another service trick. So there's another sealed flange on the 50 and 60 horsepower. It isn't used, it's just a sealed flange right there. If you got it where you can get it in the gasket for that sealed flange. When you do the oil, you can take the oil out, clean it off, pump it back up, pop that off, get a funnel, you can pour that oil right down in here. You can pour the oil in this thing in about a couple of minutes. But it's sitting there for 45 minutes trying to pump it. Just another service trick. You can do it very quickly, very easily, you just need to get a gasket for that seal flange and be sure to get it torqued down and get it tight again. Never was a fan of pumping oil.
No. That stuff's thick.
Especially PO oil, it's like molasses when it gets cold. I mean, it's just so thick. We talked about some of the 1 series compressors, some of the really old ones. And mostly those, when the Hitachi's first came out, this, it didn't have an angle valve right here. It was just a blank plate, 4-bolt blank plate. So the drain oil or anything like that was a mess. And you couldn't hardly get an oil sample out of it. You had to pop the plate off to drain the oil out and it just came out everywhere. So we had them put the angle valves on it, and we have an oil valve upgrade kit. So if you ever come across a compressor and you're doing service work on it, it's just got a blank plate on it, get you an oil valve upgrade kit. So when you take it off, you can put a kit on there that's got the valve on it. That way you can draw samples, you can pump oil in, take oil out, whatever in the future. I think we probably got most of them converted over, but I'm sure there's probably still some in the field that may still have blank plates on them.
I think we field converted some of them a long time ago.
Is that right?
Yeah, I think the ones at the ECU headquarters down here. I think Lyle did it.
Oh,
Just
probably.
drilled into that blank plate and tapped something in.
That's not
I've seen that before, yeah, we got some cores in before, I've seen that. Another strange thing about the
Drill and thread, man.
Yeah, with everything on no downtime.
Yeah. Here's some field pressure checks. The one strange thing about some of the Hitachi, some of these connections, here though, like I talked about in the motor end, those two are the common suction. Two on the side coming out horizontally at you. This one is the cylinder pressure port. That's where you can connect to monitor the pressure inside that piston cylinder. If you want to check to see where the pressure is for that piston. The one just to the right of it, that's discharge pressure. And the one directly above it, they're just right in line with each other. Those are both common to discharge pressure. That way you can have a transducer on there for a controller and another one for service hookup. Same thing over here, 2 suction. That way you got one for a controller and then one for service hookup. Now on these ports, it's like a Schrader. It's called a check port, but it just works just like a Schrader valve. Only it's got an external cone on the top of the end of it instead of a stem in the center of it. So you can push down that cone and it opens up just like if you push down the stem of a Schrader valve, but you put your gauges on there and you got a depressor in one end of your hose on your gauges. So you screw that on, it depresses that stem on a Schrader and opens it up. On the Hitachi, you can screw that on there with the depressor, and it'll still open up, but you can't screw it down far enough, and it leaks oil out around it. All you need to do is just flip your hose around. On the other end of your hose is open. So put your depressor up at your gauges, and you're opening it down here, and it'll screw right down, then it'll screw all down, it'll open it up, and it'll screw down far enough till it'll seat up. Just an easy way to do it. I had a lot of guys that just took the things out and put Schrader valves on them. You get a lot of cores in where they just take those check joints out and think, I'm not gonna mess with it. But all you gotta do is flip your hose around. That way you can screw it down on there, it will seat up, and you won't make an oily mess everywhere.
You gonna talk about the load unload cylinder port, load and unload it with your gauges too?
I can.
I mean, is that?
Yeah.
It's pretty easy to do.
Yeah.
Rather than try to energize, if you just wanna see if your slip ring's good without energizing your.
This is another trick which I've kind of laid out of the bag several years back, and I've seen some guys kind of abuse it a little bit. I'll tell you a situation of that in a minute, but the cylinder pressure port, what you can do is you can connect your gauges to this. You can connect another hose on your manifold gauge over here to the suction. Then when you open it up, that's going to do exactly what your load solenoid does, but at a much higher flow rate. Instead of going through this little bitty cap tube, it's going through the 1/4 inch manifold gauge hose. So if you've got a leak in your cylinder, and it's leaking pressure past this piston cylinder, by the piston rod, and it's trying to unload the compressor, maybe it'll load up and unloads by itself. Or, hey, I can't load anymore. You can connect your gauges up to here, you can manually load that thing up. Normally it'll overcome it, and it'll load on up. Now you might be able to shut it off and it's going to come back down by itself because it's still leaking in there, but you can actually still overcome it and get some capacity out of that compressor. I used to say this about the guys, you can do this if you need emergency, this thing's down, I gotta get some capacity out of this thing, it's July, I can't get a slip ring kit in here fast enough, what can I do? You can do that, don't walk away and leave it like that, but you can get some, open it up, you can get some capacity out of it. The only time I've seen them putting the gauges on here and open it up and it not loading is if this start stop the rapid unload solenoid, the start stop unload solenoid is stuck open. Because it's putting it in there fast as you're taking it out. Either one of the other solenoids or the piston slipper ring, if they're leaking, that should overcome it, it still should load it up.
I think when I called them one time, they told me about that, just to check, because if you're questioning if your solenoid valve is working right, and if you're not getting heat on the little tube, and you wanna know if it's something else, they said just hook up like this, and if it loads up and it does fine, and your load solenoid, something's wrong with it.
Another way to troubleshoot your piston, which this rarely happens, but we're trying to figure out exactly, be sure, for some weird reason, because we don't want to discount anything, just assume something's the way it is. Be sure that the piston hasn't hung up somehow. The pressure's changing there, but this still isn't sliding. As if your pressure in the cylinder goes up and down, my pressure comes down to suction, but my amp valve says it's not loaded. And my pressure doesn't come back up, it's just sitting there at low pressure, but I'm not loading my amp valve, still staying very low. That would tell you this piston is not moving. It's hung up some reason. 99% of the time it's because it's unloading by itself, or it unloads and it's leaking in here. And you can also check that, because you can overload it, shut it back off, and the pressure's coming back up in there. You can see it leaking back in there. If your pressure does not change, one way or the other, trying to troubleshoot it, and your amp valve does not change, then this thing's stuck. But it'll almost never get stuck. I'm not gonna say never, because that was biting the foot. So it could, but it rarely ever does that. The reason I was gonna tell you, I'm hesitant to really promote this too much anymore, and I always try to tell people that doing the gauges and manually loading it, that's not something to leave it on or try to bypass to do. I got a customer out in Baltimore who's got several compressors, and he put a
Hard piped it.
here with the solenoid in the center, and it gets down to a certain temperature, it energizes it and makes them stay at full load. I walked by and said, "Why are you doing that?" "Well, it's all right." I said, "You're going to freeze this thing up?" "No, I got to freeze stat control this thing." Don't worry about it. Jesus. Why did I ever tell that guy how to do that?
Engineer.
I can't control what people do. I mean, I try to give you good advice. I try to give you good, tips if I can, but use common sense. That's not something that's a good idea to do.
Just troubleshooting.
Huh?
Just for troubleshooting.
Yeah, it really is. I mean, it's good for troubleshooting. It really is. And those situations, like I said, if it's hot, super hot, I got to get this thing's running. I just can't get any capacity out of it. The building's hot. I got to get something. What can I do? It'll get you some capacity out of it, but that's not fixed. Don't try to hard pipe it and put a solenoid on it and say, we're good. You're good now. No, that's not the way to do it. So anyway, I'll get off my soapbox on that one. But this is a 2-series compressor. You see these are kind of diagonal to each other. This one's down and to the left a little bit. On the 5-series compressor, these two are just right across from each other, but it's still the one on the left is your cylinder pressure. The one on the right is discharge pressure. That's the only difference when you're looking physically at those compressors. Your old drain valves down here on the bottom. Okay? You can see how these are oriented, these capillary tubes. The one going up over the top, always remember the one going on the top is your load cap tube. So that's the one that's going to get hot when you energize the load solenoid. This is the normal unload. And sometimes when you're checking that temperature, this thing's been running, you may get ambient temperature. I mean, it may be warm, but you'll feel the temperature difference between the two whenever you're flowing hot oil through the one of them. You'll feel one of them heating up. If they both get equally as hot, that means whichever one is not energized, that's the one that's leaking by. It's not seating up internally. Just calling it another solenoid valve. I think this is just another picture of the same thing. Wall side glass. Top view of the solenoid. Just some more information on fuel pressure check ports, and like we were talking before about checking the differential across the strainers, where the suction strainer is located, right there on the suction end, the suction belt housing. And checking the cylinder pressure control. When the compressor is fully loaded, the pressure in the cylinder is going to be right at suction pressure. When the pressure is fully unloaded, the cylinder pressure is going to be right at discharge pressure. When operating the compressor between fully loaded and fully unloaded, the pressure in the cylinder will be an intermediate pressure, but that's not linear. So if you put a gauge on that port, that cylinder pressure port, and you start watching this thing as it loads, it doesn't just slowly drop down to suction pressure, and it doesn't just come down and even. It kind of, I don't have a great explanation for this, but it goes in kind of spurts. You'll see that pressure and it'll drop a little ways. And it'll sit there for quite a while. You see the amp keep coming down, then it'll drop again, then a little bit, then it'll drop on down. I think there are ports inside this cylinder that monitor that. So as this piston slides over, that's when those pressures kind of change in stages. You don't see it just, you're not reading out of one port on the very end. It's reading out several little ports on there. So don't judge that as far as exactly where you're at as far as your percentage of load. That's why I say you can look at it really to kind of determine, for serviceability, to try to load or unload it, to see if it's fully unloaded or fully unloaded by pressure in the cylinder. But look at your amp draw to really determine, is this thing fully loaded, or is it 50% load? Well, where's my amp draw? What my full load amps, what it should be. Is it 100 amps? Well, am I at 50? Where am I at? Amp draw is really your best scenario to judge percentage of capacity you're at the time. Pressure should remain fairly consistent in the cylinder port while the compressor is in the stable operating conditions and the compressor solenoids are de-energized. So again, no matter where it's at, if your solenoids are de-energized, you should hold at that state no matter where it's at. Full load, mid load, you de-energize the solenoids, that's where that compressor is going to stay until you make some sort of an action of energizing something to either bring it up more or bring it down. Then I put in some schematic drawings here for just your operational information. You can see here the winding drawing. This is why, see, UX is one phase, VY is another phase, and WZ is one phase. So that shows you the only way I'm going to get an ohm reading is go between these two. If I went between U and Y, it should be open line because there's a break right here and there's a break right here. Unless you've got a cross-line bars on there, you're still going to get a reading. That's why you got to take those cross-line bars off too. You don't want to have anything on those terminal plates whenever you ohm it out. And that way, whenever you're ohming out between this, and this, you're doing a phase-to-phase ohm. You're checking for a phase-to-phase short. You should always be open line if you're ohming out between any of these other phases. If you get any kind of resistance at all, that's a big red flag. I'm getting a phase-to-phase short. This motor's getting ready to go out. I can't, if the motor's tripping out on me, I'm not getting any kind of meg ohm to the casing, I'm not getting resistance at all. It's ohming out pretty good when you go phase to phase. Am I getting anything there? Oh, hey, I am between U and X, or U and V. Well, you got a phase to phase short, that's what you got. And this shows your Y delta start, so you'll have 3 contactors in there. Also shows the standard module, how it wires up on the side. Okay. There's a 100 horsepower compressor. Again, some of the stuff you guys may never come across, but I want to be sure you're provided whatever I've got. And if you ever come across one, you may have that information to do it. Here's your direct start with your cross-line bars, U and Z. So now we're jumping across here. U and Z, V and X. You join those together. WZ or WY. That's where your cross-line bars are connected. And that's a direct start. There's pros and cons for both sides. I mean, your Y delta gives you a soft start. It's less inrush, less harsh. It's a softer, like it says, it's a softer start. Direct start, there's nothing wrong with that other than it's just it's a hard start. It's going to hit and it's going to run. A lot of people do the Y delta, but if you don't want the expense, sometimes, well, I don't want to put 3 contactors in there. I just want one. Well, your direct line starts what you have to do. less expense. I think that's what a lot of people look at when they do that, you know, how much money can I cut out of this unit? You know, OEMs are always the bottom dollar. You know, I hate to knock them, but it is what it is. How much less piping can I put in here? How much, you know, less components can I put in here? That's why I've always said, you know, OEMs do not build a unit for serviceability. I think everybody in this room can probably agree with that. They don't build a unit to make plenty of room in here where I can come in here and I can really work on this thing. You gotta stand on your head, or how am I gonna get back to that back there? I gotta take the back panel off this unit just to get to this component. It's ridiculous. And here's the same thing with the 2 ACE module, shows how it's all hooked up on the side. It's a 100 horsepower compressor with the crossline bars on it. Here's the same thing, the direct start, only it's got the small module on the side. Just try to give you as many variations as we can in here, but you know, it's the same drawing, the direct start, but it just shows the different motor protection module on the side. Sometimes these drawings can come in handy, especially in the field when you get up there, and I know, you know, every unit's always got the original book in the unit, easy to get to and very easy to read.
Clear, concise.
Yeah. Water and mice and everything else, mold and everything's gotten to it and it's falling apart. Sometimes these can come in handy. Then we talked about permissible voltage. This just gives you a chart showing you the 50 and 60 hertz, 10 plus, 10 minus percentage. There are some compressors out there that are they'll show 208 volt. The Hitachi 230 volt can be put in with a 230 or 208. There is a true 208 out there as well. I mean, we have had some of those in the past. We wound a 208, but the 230 will work on that as well, just so you know. This gives you permissible plus and minuses on your voltage. So 230 volt, you can go to 207 or up as high as 253 and still be in good shape. Some torque specs, flange bolts, motor cover bolts, electrical terminals, oil separator. Shows you the size of the bolt heads as well as the torque spec for it. One thing I do want to stress is on the terminal plates, 2 series as well as these 5 series, but on the 2 series especially, so anytime you tighten down any of these bolts on top, be sure to put a wrench on the bottom one. That way you don't spin the stud, because that can actually create a leak. Especially on the ones with the grommet in there that's baked and sealed and, you know, kind of baked and stuck to the side, so if you spin that thing, you could cause a leak. And it's, I think, 21.7 foot pounds, so it's not really a heavy torque, but you still want to put your wrench on that bottom nut before you torque the top nut. And you got double nuts on top, you know, one to tighten down, another one's for a jam nut. Definitely do, it's a good idea to use that jam nut, that way it keeps it from vibrating when you get it loose on you again. In the 2 series, you got those black cups. They're like arcs, insulators. The terminal is a 19 millimeter or 3/4 inch, but it's hard to get a standard wrench inside that cup. What you need is either a narrow head wrench or take a standard wrench and grind the head of it down just a little bit, and then it'll fit right in there. But if you get a standard wrench, it's hard to get in there, and you'll wind up cracking one of those insulators pretty easily. Just a FYI. Nothing in the book says that, but it is.
So if those terminals leak, you just tighten them down?
The what?
If those terminals leak?
If they leak? You can do that, yeah. There's a metal gasket right here where they screw down into here. You can just try to tighten it a little. On these especially, you can try to tighten it and see if it seals back up. But the 2 series, I wouldn't do that because it's the grommet there, and I don't know if any time a guy has done that and actually caused it, you know, we probably can try to tighten it, but I don't think it's gonna work, but you can try it, and it almost makes it worse every time. Now these 5 series plates, yeah, if you had a leak right there on the terminal, down here at the base, you could snug that a little bit, and it's threaded right through there, so yeah, you can do that.
So that rubber looks like it expands.
There's no rubber on this one.
Or whatever that piece is that's going through the metal terminal plate.
Right here?
No, down below, right there in the red section.
It's like a crush ring.
Oh, that's just thread, that's metal.
Oh, no.
The ceramic right here, there's ceramic right up here on top of this, not this base piece, but right here. So you want to be careful not to crack those by putting a wrench on them. You wanna turn it, tighten it on this outer nut right here, base. And it's, I think 36 foot-pounds, so it's not that big of a torque. Yeah, you can snug that a little bit, see if it'll seal up.
Cause that's what's actually doing the sealing, is that nut. Where's the seal at?
There's a metal gasket right here.
Oh, there is a metal gasket, like a crush.
That's the new style though.
Yeah.
The older ones had the O-ring in the
The
middle.
rubber.
Yeah.
The old ones that got the O-ring in the middle, or the grommet in the middle, they started leaking, basically, call me get a plate. Just change out the plate.
I got lucky then when I did.
Huh?
I snuck one up, I got lucky, I guess.
Yeah, if you stuck it up, it
I
quit.
tried a couple of
So
them.
Don, do they even do you even, do the,
The things you probably snuck in that tight.
are all your rebuildable ones the newer style? So if I got a new plate, am I still gonna get the old style?
If you buy a 2 series compressor, we still put the 2 series plates on.
You do? Okay,
Don't ask me why.
okay.
Can you get that series of plate?
They'll bolt right up.
2 series?
They'll bolt right up, okay.
If you have a 2 series plate that's leaking, you can buy the 5 series plate and it'll bolt right up. It's got the same designation as far as the terminals and everything. It's interchangeable. It'll drop in and drop.
Is that better to do then? Because it holds it better for the seal?
Why? Yeah.
Well, that's good to know.
So you gotta specify that.
I'm not here to promote
No,
that.
I know you're not.
But it will. I'm not gonna lie to anybody. It will.
All right.
It definitely will. And if you got a 2 series plate leaking, buy a 5 series terminal plate. You'll be better off. Yeah, if you tightened up a 2 series stud and it quit leaking,
Maybe it was 1 series, I don't remember, it was a long time ago.
1 series and 2 series have the same plate.
I've done it, just it's really easy and you don't wanna overdo it, and just cause it's almost like a little bit looser vibration, and I've had it seal up a few times too.
Good. I'm glad to hear that. Most of the time it won't. If it's leaking because it's cracked or something like that internally, yeah, most of the time.
Gallery over there? Again?
But yeah, if you guys want a 5 series plate, they'll bolt right up.
Stuff like that,
Get stud, you got a backup wrench on the stud.
Well, yeah, up top with the jam nut, right, but then do it low too.
These are the 2 series torque specs, which are about almost identical.
Housing.
Yeah.
Extending them. I needed a good option.
There's the assembly and the torques of the stud on the 5 series plate. So if you said you wanted, I got one leaking for some weird reason, I need to change that stud, this is what you get, the entire thing. This gives you the torque specs, you know, top stud needs to be at 22 pounds. The base, which is this nut right here, right on the top of the plate, if you screw that down into the plate, is 36 foot-pounds. And each of the power lead connections are 22 foot-pounds.
No sealant, no nothing, just clean, okay.
Clean it off good and clean, metal gasket goes down, torque to 36, you should be good.
Okay.
You can if you want, but you don't really need it. Loctite's universal, right? Kind of like duct tape. And I got an exploded view in here, the
Oh, cool.
2 series and 5 series. This is the 2 series exploded view. And then also there's a sheet that shows the standard parts list on that exploded view. Some of the parts are the same for the 5, all 3 of them. Some of them are like the strainer. It's the same on all 3 models. Some of them are a little bit different between the 40 horsepower, 50 and 60. Most of those have the same part numbers. But again, this gives you some of the our inventory part numbers. Now sometimes you get parts from us. Hitachi has a sticker on it. Starts like with a H5104. Our part number might be a GSK1803A. So you may order that, your picking ticket shows that, your PO shows this. If I get a gasket that says an H5103, that's just the Hitachi inventory part number. I had people call us before saying, this isn't what I ordered. I said, what do you mean? Well, the numbers don't match, It's like, and I've gone back to parts before and tried to get them to label our part numbers on our stuff. I'm not gonna go into that. Do you know how long it's gonna take me to, come on. But anyway. Don't get excited if you have an H number on there, as you ordered a GSK 1L4A or whatever. And then there's a 5 series exploded view, which might come in handy, just trying to figure out, well, I need this part, but I'm not really sure what that is. And the standard parts list for it. and the parts list and exploded view for the 100 horsepower compressor. And another, if you're trying to get your customer to replace a compressor it's running with this thing, or hey, I want to do a slip ring kit on it, but this thing is 25 years old. How many hours do I have on this thing? This is a technical bulletin from Hitachi, the bearing manufacturer, showing related run hours for a recommended overhaul. So before 1994, a water-cooled unit is every 20,000 hours. On an air-cooled unit, it was 12,000 hours. After 1994, it went to 40,000 and 24,000. Now your compressor may go a lot longer than that, but you can, I've had some guys that say, well, what's the recommended overhaul on this thing? When is it? And you can show them this. Well, this isn't what the compressor, Hitachi doesn't do it, but the bearing manufacturer, the bearings inside that compressor, they recommend overhaul or change the bearings in this many run hours, which usually you're going to well exceed these many run hours before somebody's going to change the compressor out. But they just give you some technical backup of, hey, this thing, doesn't owe you anything. It really needs to be overhauled.
What was the change? Bearing type? Bearing type?
The bearing type and the heat shields were a higher temp. They did different material, that kind of thing. So they almost did double the lifespan of them.
But a rebuild is a whole new compressor, or a rebuild, you're not doing that in the field.
No, what you'd recommend would be, just buy as a remanufactured compressor and swap it out. That's what you really need to do. Now, if you have, like I said, we can do on-site. This is pretty far to come. The closer you are to us, the cheaper it is. But we can do on-site rebuilds. We have done them before. We've gone on-site, rebuilt a compressor, didn't change the motor. The motor checked out okay. The guys go, okay, let's put new bearings in it and let's just go through this thing. We've done that. Of course, we only warranty what we change. So I tell them, well, we can change the motor, or we can leave it as is. But if the motor goes out next week, I can't warranty that. But it's one way you can overhaul it without having to do a complete rebuild if you didn't want to. I'd recommend just pulling it out and replacing it with a remanufactured compressor.
We got to pull it out anyhow, right?
Huh? We
got to pull it out anyhow for you guys to go through it.
Yeah, exactly. Right. Yeah. We looked at it when we first started looking at on-sites, about coming on-site to do the rebuilds. But we would have to do permits from every state all across the country for our guys to come out, go to the roof, pump it down, take it off, rebuild it, put it back on. So what we recommend is, what we require is, we came out to do a rebuild for you. You guys pump it down, pull it off. My guys take over, they rebuild it. You guys put it back on, and we stay for the startup, be sure everything's good. You guys sign off, then they leave. We only work on our product. We can't really put our hands on the unit. That gets us out of having to buy permits and being, liable for what's going on in the unit, other than that compressor.
So quick question, how long would, if I did short one of these to ground, say one of them went to ground,
okay,
one of the motors, I had the thing set out, how long would it take those guys to rebuild that compressor?
Well, we can rebuild a compressor in a day, easy.
Okay.
Usually a little bit less than a day. Usually it's about one a day, depending on, most time-consuming thing on the old compressors when you rebuild them was taking them apart. Some of these old gaskets are just like rock on here, trying to scrape the gaskets, get it good and clean, all that kind of stuff. These gaskets pop off real good. They can do it pretty quick. Within a day, pretty easily.
They can get the motor winding out in the field?
Yeah.
About baking the whole thing?
Yeah. Now we got special jigs to pull it out and then press it back in. It's much easier if you got that casing hot, but it does go in much easier. But we can press them in. That's why we don't recommend in the field to take special jigs, or for you guys to say, hey, can I do it? Well, it takes special jigs to pull all this stuff out. I was talking about earlier about these bearing supports in here. You got a jig to pull it out, then you got to freeze them to get them back in. And there's certain things like the little feed hole on this thing, if it's not positioned just right, this thing can go in a month, you may fry that compressor, it's going to lock up on you because it's not oil. And it's like, what happened there? Then we pull apart, find out what's going on, and go, well, bad news. So you can do slip ring kits, that kind of thing, but that's about as extensive as we'd like for you to get in the field, as far as doing service work on them, internal work on them. Warranty period, 18 months from ship date or 1 year from startup, whichever occurs first. We do offer extended warranties. Really about as long as you want, 4 or 5 years if you want. It's an additional year per additional, $1,000 per additional year. We can offer that in 6-month increments. So if you buy one for a year and I want additional 6 months for $500, we give you an additional 6 months. Or you can go as far out as you want, really. But really, rule of thumb, if a compressor's got a defect in it, it's not going to last very long at all. It's going to go out pretty quick if it's got a defect in it. But a lot of people, they just like to have that extended warranty. In here, I do have the warranty for rebuilt, and 12 months from ship date or 6 months from startup, which I need to pull this out because as of last November, our rebuilds have the same warranty as a brand new one. They're all 18 months from ship date or 1 year from startup standard, and we offer extended warranties on anything we sell. Then I got a compressor information guide. Just something that's kind of good to keep on hand, or you make copies, for other compressors, just a little record sheet for you of what type of oil's in the system, how much oil did you add, when did you do it, that kind of stuff. I get calls all the time, guys wanting to put oil in the compressor or the unit. I got this job, I want the unit, I need oil for it. What kind of oil do you have? I don't know. What do they have in them? I said, well, I can tell you what it came from the factory, but I can't tell you for sure what's there. Because different people get their hands on it, you never know what's happened. So records are always a really good idea to have. History of maintenance, like I said, just put another form in the manual, that way you got stuff you need to jot down for any kind of maintenance you've done on something, like a slipper ring kit on this date, or dates you've changed the oil or anything like that. And put a copy of our compressor startup sheet. It's a 4-page sheet which comes with every compressor, but I put a copy in the manual as well. Shows you most of the information we've talked about today on the safeties and all that, things we want you to check, be sure in place. If you do get an extended warranty, we do require that you fill this out and send it back in to activate that extended warranty. In the years past, we haven't policed that, saying that every compressor goes out, you have to send that back to have a warranty on it. We still are going to cover it if it's a defect, no matter what. But if it's an extended warranty, we definitely like to have that startup sheet back. That way we know when it was put in, what kind of conditions it was put in, how the system was running. This is the last page of it. Just shows the voltage, that kind of thing, amp draws, what was the oil level at full load, or what percentage of load was that when you took it. Strainer delta on there. It's got the oil pressure, then the strainer delta. That's the pressure differential you would take across the strainer. Check the angle valve, compare the discharge. That's what that reading would be. It's kind of throwing a few guys in the field. What is this? Pump down cycle, if you got it, document that kind of information. And then suction superheat, document that. I mean, that's kind of a critical one. Make sure that superheat is in where you want it to be.
Maybe take 10 minutes. Food's here too. So.
Yeah, absolutely.
You didn't know who you were in? You had to put your order in, huh?
We got
It's on me before you get
Do we have to sacrifice it? How does that work?
We're not sacrificing.
Sorry, good.
Hey, Brian, can I take you got your puller? Who's got it?
Place working on my truck.
What?
Place working on my truck.
Didn't you buy one?
Oh, Andy bought it.
Hey, do you have a 6-foot ladder in the van?
I'm working on your truck.
Show your guys, we have ladders.
It's on the side of the Connex, if you want it.
What?
Oh.
Yeah, it's on the side of the Connex.
Shit.
Oh, is it that fucking?
Where's that at? I'm gonna have to go to Granger. They have them in stock?
Here you go, Adam.
I'm
You got your
sure they
salad.
did when I bought it.
What? Oh, thank you.
Sorry, buddy.
What do you need it?
You guys ready?
No, never had a chance.
I think it's awesome. You should have Andy leave his in the truck. I can't imagine you use that thing too crazy often.
Actually, mine might work. I don't know in your mind, but I haven't feel it back.
I cut mine out.
Oh, you notch.
We'll see.
units for
I don't think they had them stock.
I would buy one in this.
Well, that's when they were looking too, they couldn't find out what it was. Andy found it.
You wanna be healthy?
Cheap.
I gotta take the class.
Are you going down there?
Yeah, they're gonna give me a makeup day if I go to the class.
There you go.
They'll give you a makeup day?
You're supposed to take a wholesale.
And I have class tomorrow anyway, so
I guess we'll wait and see how much
I'd be
is left.
skipping the class, to retake this class, and get the makeup day. I'm like, yeah.
Are you in the morning or
Just in the class or keep
It's gonna be afternoon, that's my normal afternoon class, so it's down there.
Cause they're, he's doing something in the morning. I'm taking this thing, that compressor down to 7.
Making sense?
Jeez, we're just getting pimped by the
We might have a date
around
card.
Yeah. What?
What?
Like it's open to all the members. But yeah. Imagine it's quite
Yeah.
different.
But the other half
They're gonna
is.
show up, and that's what I wanted to do, listening to the smaller stuff.
Hey, take this. Take that sucker out.
Jason, you're a fifty, right?
He came into my, Glenn came into my class and put an announcement, you know, for the whole, all the fourth years this year, what, about the.
That's
training
cute.
class.
Yeah, good deal. Good makeup day for it.
Yeah, that's neat. Yeah.
I got, they put this thing class on the wall tomorrow.
Aren't you doing your thing tomorrow?
No. Yeah.
Pastor?
I'm doing that in the morning now.
Yeah, barely.
This class is in the afternoon.
No, but I'm hoping you do so well.
Oh, we can probably go get some.
Yeah, just think of it as light if it won't kill you.
Oh, here's mustard, Brian. There's mustard in there, here. Not more than one?
For a beer?
Huh?
You want the rest of this one?
Who? Who want mustard?
Need to recover.
Got mayonnaise?
I'll give.
Right, tastes like sugar.
So here for what people put over it.
Or the,
I'm wondering if you have a proper buildup. I mean, the places that bring, making it better, if they're like, hold it out, or.
Well, you replace that, the shaft that you believe.
Yeah, but the outer people, so, the casing.
That's the problem.
Oh, I thought you replaced both seals, the little guy right there, and then.
On the piston one.
One piston.
Sure.
When you change the slipper ring, you do the big piston gasket too?
So what if there's, what if there's buildup on the inside of the piston bore?
Bore, you just take some, emery cloth.
So there's nothing specific.
You don't wanna
necessarily.
bore it out, just take up the spine, very fine, just gotta smooth it.
Right.
Really good spot. You get a new piston rod as well. The rod looks okay, even if, you know, that's, you could smooth those down, they'd probably be okay. We'll put a brand new rod in the line as well.
Yeah, once. He's got an oversized machine. He's got just that one.
Oh, there's two. No, cool. Thank you.
So I don't have to go in.
What?
Skip the class.
I had to put on my.
Yeah.
Yeah, I did that.
I just have to go in.
Or even like,
Hey Grayson, where was that flooring that we missed?
The other part of the slipper ring.
Huh?
It's the other half of the slipper ring.
Down here?
Look, if you look in the cutout, there's a white and a black one.
Yeah.
The black one sits in there, you can't see it.
Oh. That's good. Oh, that's on the plate. On the plate. What's that?
Pretty sure that's what it was.
No, it wasn't. I knew we didn't miss that one.
The plate, no, we didn't do.
That's the fucking one that's a pain in the ass.
Well, I had to reach in there and get it out with the O-ring.
He's getting any sealant on them? They just throw it in there.
Oh, yeah, it was on. It was right on the back of that.
Yeah.
Oh, you forgot the slipper ring.
5.5 that thing, damn it.
We went back. That's this
We took it
down
down.
here to keep your ribbons from going inside between this stud and this guy. That hole. That's the over here. Oh, there's gotta be
That's how he said to do it. Pinch that thing like it shows in the picture.
I know you got to put a lot of
Oh, we can take those out.
You don't pinch it, you need to.
You can bend it out and then you see the pair of.
Good, I'm not sure.
Yeah.
But now it comes to soon.
We can pop that out and see how it's built at least. Yeah. So it looks like it's right around like. Somebody's put.
No.
Probably has, and you can see on the breakout of it.
Hey, Don, will 1 foot support the whole weight of that compressor?
What?
1 foot support the whole weight of that
Do your
compressor?
fingers, you can't see what you're doing.
Would 1 foot support the whole weight of it, I mean, as far as lifting it?
As far as spinning it out, will 1 foot support all that weight, do you know?
Probably could, you probably pushing it to the max on it, but you probably could.
I got some metal.
I know, yeah.
I don't think I've ever seen one break off, except for unless you dropped it off somewhere and break the foot on it.
Okay.
I think probably.
Yeah, they're all metal.
So, grab it.
No way. Watch Grayson struggle for an hour, then half a second.
Never ate strawberry leaves.
I've never really done that, so prove that.
They'll be coming out in a little while.
Yeah.
Too much healthy food. Your grave.
Oh,
Yeah.
That's about 175 pounds. I know that what's pretty much unload, when we get in there, we'll talk about the slippery.
I wonder why.
Break that loose and find out.
Wait, what do you mean?
Did they go? Actually, 1, 2, 3, 4, or is it 1, 2?
I've never seen it, I've never seen it.
I'm not sure.
Depends on the federation.
Yeah. Now that you know.
Yes, there's.
But only one. They were lighting off and then shutting it back down. They weren't getting the danger signal.
Yeah.
Which I.
Oh, yeah, my hands are small enough though.
Yeah.
I've never
Yeah, but if you just hold it out there, you just stick it in there, open your needle, like
Yeah, I mean, I want to change the igniter so that we want.
it's right here. Add it or replace.
Well, we have.
I like-
We look for
Yeah, you guys are happy.
Yeah, we can.
That's girl hands.
Leave it how it is.
Oh, you want another half of those
3 out of
sandwiches?
4 of them will light off. I don't know how.
I really do.
I'm stuck on the salad.
Noble texted back.
Oh, I think.
Exactly where they were.
Yeah.
So Mueller went
Kind
out
of
and
40 degrees.
so I guess they replaced them the next morning. Dean went back out there. Oh, really? Throwing. But, you know, when I was there, like, not really doing anything that was really, anything that was leaking out. Because when they go off, they say, oh, air flow.
Pretty big.
So they might for like a second.
That's probably the most tense part of getting that white slip ring in there.
I don't know if it was something in the pressure switch.
Black one's got little grooves, so it's easy. That one. The white one you can get in there,
I
but
was thinking that too, but like, I couldn't get to them.
No, there's no way to get
I was gonna get it separate, no, it's separate material, put the black one in there and get the white one.
Boilers there.
Yeah.
Like,
The fans have
I wouldn't try it.
I think that picture is actually both.
No, it's got.
yeah, by the time I left, it was like 11:30. Because we got the temperature up and the water temperature.
You can even drop down, if you got real hot water or something, drop that slip ring down and that to soften it up, just wipe it off good before you put it in
And
there.
Mueller
Put
was
it
like,
on the discharge.
everyone's in for the night anyway.
Yeah.
Oh,
You seen that Hanbell?
I didn't feel right.
Yeah,
I was like, really?
What I do.
I don't really have a.
Yeah.
You just reset it.
Oh, yeah.
It's like 4 times. And then just looked around to see if I could find safety.
Yeah, that's the one.
But yeah, the disgusting.
So you don't like onions either.
They're showing pictures of it, don't they?
Yeah, we rebuilt a couple of them.
Yeah. Several years back, we had,
Down to the bread.
Yeah.
Brad, one of those guys.
Went out, I was came around the corner, that was all chased the fence.
Don't do that anymore.
Red yard. They don't?
Actually, I'll tell you that, I'll tell you they don't rebuild it. Remember they sold you the tooling kits?
Yeah, now they do, now they have all this setup down there. That was just there last month. They have the whole setup. Really?
6 months.
This is where I came through.
There was really nothing to it. It was like,
How was it? Was it welcoming?
Oh, yeah.
no problem, this would.
The first 8 grand to get to.
That's the whole point.
Yeah.
Someone's gonna cut the order, you go,
Very.
Upstairs and then into the electrical rooms for those Aeon.
I don't want to pass the female.
Oh, Bill.
Yeah, I had to walk past the veil.
One of those little perks they don't tell you about.
Churned all over the sand. Do the showers. Got all turned into a frost. Pump back.
Yep. Male showers in the middle of summer when they had no air conditioning.
Slaving away.
Yeah, that's a good place to be.
You'd be wearing sandals in no time.
How's it going?
Picture.
Growing your hair.
I'm growing it out.
West side.
Placing that dry
Just don't ask which hair he's growing out.
Didn't we have class
One of the
together?
Aeon units
Mo?
Yeah.
and
Were you in our class?
drive shit out, so I just wired it, just bypassed.
You
the
kind of
drive.
bounced around.
Oh, yeah, yeah,
You did your own thing.
Would be the reviewer too.
And then I went into the 5th year. Cause as a tech 3, you come in and do different.
Yeah.
The first 2 years and the 3rd year.
That's our five, that's the deal.
That's, I know what you're talking about.
I just followed, I just
That's our
like.
Yeah.
But you were ready to parts.
Is it, where is it out back?
Come
I
out.
always think,
Right.
you guys have one customer that spare?
Possibly, I don't know. Todd is on it. Is that-
So you just keep.
No, I'm not sure what they're.
So, right, you might want
It's
to
not
30.
Yeah, I don't know what they're.
They're doing maintenance
They got
with us, and they don't seem to really do anything.
They spread apart. Work with St. D, but it's kind of rare.
In the minute something's not working right.
Yeah. New,
Emergency.
200-ton mammoth.
Just things, recommended things to check for preventative maintenance. So we've got some troubleshooting sheets here. If something's wrong, okay. I can't tell you how many times I've had to walk away from jobs. I've looked and just knocked my head against the wall for hours and kind of got to walk away, clear your head, and come back, and dang, it's the simplest thing I ever thought of. Sometimes it's good to look at just kind of a troubleshooting sheet. Okay, this is what's going on. Let's look at some scenarios that could be that, rather than me sitting here trying to figure it out. So how, loss of your main power. That's one of them. Control voltage, loss of your low voltage, 120 volt control power. What could be causing that? What are some solutions for that? So just put in here, like I said, just some preventive maintenance stuff, some troubleshooting stuff, and solutions for that. In the very back, or one of the back ones, I've got handwritten in the slipper ring kit replacement required. You can see at the bottom on this one page. Kind of wrote that in there because prior to me coming up and doing a lot of these, when it got to the slipper ring kit was leaking, they just said you could send the compressor in for service or replacement. We didn't have a kit. And I kind of beat up the guys in the office and said, they could do that in the field. This is something you guys could do in the field. So finally got an agree. We put together a kit so you guys can do that kit in the field without having to buy another compressor. And always talk to the guys when they're buying these kits though too. I mean, there's always something to consider. Okay, I got an old compressor. It's got a slipper ring kit leaking on it. Hey, I can do that, right? Yeah, you can do it, but okay, is this a 1988 compressor? This original compressor sitting there? Just something to consider. It's been working great. I'm not going to knock that, but if I want to pull this compressor off the circuit, put a couple $1,000s into it, well, probably several by the time you put your labor and everything into it, put it back on, and I've still got 30-year-old bearings and everything in that compressor. Or is this thing really just time to replace the compressor? So just kind of weigh that out with your customer and kind of their approvability of, I ain't got the money to do that, or no, that's really probably the best way to go. It hasn't failed on me yet, but this thing's really old. We got a loading and unloading problem issue. We can patch that up, or let's just change the compressor out. Now, if this is a 5-6-year-old compressor, no, I wouldn't recommend changing the compressor unless you had to. You should have a lot more life left or something, but if it's 25, 30 years old, something to consider. Then, some people like flow charts, some people don't, but I put some flow charts in here as well. This is what's going on. Okay, I checked that yes, that, no, okay, go over, check this. Just another troubleshooting flow charts for electrical. I've got some capacity control flow charts, troubleshooting flow charts. Then I got the copy of the manual. With every slipper ring replacement kit for the Hitachi compressors, there's a manual that comes with it. It shows you step by step how to do it, illustrated pictures. It's a pretty simple procedure, but there are some things you really need to know. Disassembly, taking it out, each step, what tools are required to do that. The size of the wrenches you need, torque specs, all that kind of stuff's in there. Like I said, as we put together the steps, it gives you illustrated pictures. Okay, should I be seeing when I'm doing this? Draining the oil out, taking the separator off. Now the oil separator is one of the big ones we said a while ago. That separator is about 175 pounds. So separating kit isn't really something one guy should try to do, just because of that almost. If you take that off, we recommend putting some guide rods at about 10 o'clock, 2 o'clock, so that you do have break-off holes, push-off holes at 10 o'clock or 12 and 6 o'clock on them. So take your bolts out, this thing didn't break loose, okay, I gotta break it loose, it's gonna drop. You have some guide rods on there, or at least these 2 bolts on here, not all the way out so it doesn't drop on you. But then the guide rods would allow you to slide that separator back so 2 guys can grab a hold of it, slide it off and set it down. One guy doing it, I don't want you to throw your back out. And even a pretty hefty guy can do that when you're off out of an angle like that. You can hurt yourself if you're not careful. So you take them all out, put your guide bolts in there, and you can slide it back. It's not really that difficult a procedure to do, but there are just a couple steps like that you got to be very careful whenever you're doing it.
Does it tell you the thread pitch? Or does it tell you the thread pitch you need for making guide rods? Because you're going to theoretically take a longer bolt and cut down, right?
Yeah, I think we got the
M16.
it's got the and the stud bolts, M16s. Gives you the thread size and stuff. It doesn't come with the guide bolts.
Oh, it comes with the guide.
It does not come with the guide bolts.
Just get them a Tacoma screw. Just take one of the bolts down to Tacoma screw and get like 4 or 6 of them, tell me what. Just cut the end of get the 10-inch or 8-inch and then just cut the end of the head off.
Yeah.
Right.
Just you do that. Or even small thread, something like that, with the right thread on it.
Yeah, it's an M16, right?
Tell you the thread.
Tell you the pitch.
Yeah, when you do this, get all your tools, 'cause you got metric tools, next wrench, metric, and your whole
Mix them all up.
Huh?
Mix them all up. Yeah, it would be metric, wouldn't
Now,
it?
if you don't have the right metric tools, you're gonna get there, you're like, oh man.
We're taking that back plate off. It's always a good idea to take all the bolts out except for the one at the top and loosen it up a little bit. Get you a plastic mallet or rubber mallet. Then we can hit the edge of that plate. This back plate right here. That way it'll pop loose and doesn't just fall on you. Plus there'll be some oil in that cylinder. Even though you evacuate it out, there'll still be oil in the cylinder, so it's gonna run out whenever you pop that plate. So it's a good idea having just a little pan or something down there. It won't be a lot, maybe a half a cup will come out of there, but have something to catch that. Of course, stick any rags and stuff, any holes, anything when you're scraping gaskets. Be sure when you're scraping gaskets, you don't gouge the casing too. Just be as careful as you can. You don't cause a place for a leak to happen. Slide that piston out, take the slip ring out. The piston, slip ring off the piston, we call that a slip ring too. It's a large slip ring. To get that little slip ring out, we recommend if you can get like a half hook little dental pick, you can reach in there, kind of grab it, pop it right out. Comes out pretty easy. Again, when you're putting it back in, it's all just assembly. You pop the piston out, start taking the bolt out, get it out most of the way, then put your fingers around the end of that piston until you take the rest of it out. That way it doesn't pop out. That spring, sometimes it will pop the piston out. Sometimes it won't. Sometimes you gotta pop it in and out, then it'll come out. But that way it'll prevent it from just popping out and oil coming out as well. Then you take your piston out. One little trick is this piston's got 2 little threaded holes on it. That 4 bolts, 2 bolts, little 4x4-inch box on the side of the compressor. Those little bolts on it that hold that on there, they screw right into that piston. So if you want, you can take those off, grab them. That would give you a couple handles to pull that in and out. You kind of see those screws there. Take it out, take the piston out, slide the spring out, grab that piston rod, pull it all the way back to you. That pulls that piston, or not the piston, but the slide valve. Grab hold of this rod, you pull it back, so you pull the slide valve all the way back up against this casing. That way it'll make it easy when you put the other one in to thread it right back in there. Plus a little bit of a backdrop, so if your slip ring does try to fall in on you, something will hit that rather than falling down into here.
How many extra Teflon and O-rings does that kit come with?
You can buy as many as you want. Comes with one. No measure for error. Then just reassembly, basically, putting it all back together, tighten it back up. The little Teflon, heat it up whenever you put it in. Don't try to put it in cold, because on here you see how you kind of bend it, and then you try to get it up in there. If you do that when it's cold, you're going to crease that Teflon ring. So you want to heat it up so it's nice and pliable. So you can bend it up, kind of a little curve. What I recommend is get a long needle nose, head needle nose. That way you can pinch the end of that and get it all the way up in that cylinder and fit it up in that groove and let it go. Then get your hand up in there and try to smooth it out with your finger. It works. It should work really well. Just kind of got to hold your head just right and get it up in there. But you can do it. Black one goes in first. The white one goes in up on top of it. The black one falls down into the groove. And the white one goes up on top of that. That's where the rod slides on the white one. Put it all together, torque it back down, assemble it back up, you're done. And again, this will get the cylinder sealed up and you'll start working, it'll start loading and unloading. But that wasn't the problem. You know, copper plating is a problem. So this is just a Band-Aid. If you don't address what's in the system, contamination of the system, 6 months, a year down the road, you're gonna be back in the same boat again. And you call me and wonder, why is this slip ring kit not working? It must have been defective. Well, did you clean up the system? No. Well, you know, just plate it back up again. So you gotta address the problem whenever you do it. It will get it going, but you gotta address the problem.
But changing the oil, changing your dryers should
It's always a good idea.
help clean your system up.
Yep.
Get in the right direction.
Is it the plating on that rod? Is that what's taking it out?
It's usually, well, if it's plating up on the rod, then you get flakes and stuff that'll plate on the white Teflon ring. And that white, when it starts hitting that Teflon ring, it creates the leak then. You see the groove on the rod from hitting those little pieces of copper on there and sliding back and forth around. But this will turn kind of copper color, but it doesn't really plate on just cause of leak. It's all that Teflon slipper. Sometimes you take that Teflon slipper out, you see little flakes that are just stuck to it. Pop them right off. And in the back of every book, you're going to see a contents page. That'll show you everything that's in that kit. So when you get it, there should be everything in there. Remember how I told you some of the Hitachi numbers are on some of the bags and some of them aren't? On this cut sheet, it shows you the Hitachi number as well as the Hitachi number. The Hitachi number as well as the ACCS number. So if you want to call and order a part, you can call, you can tell us either one, but if you give us the AC components part number, that can tell you right away. But this will tell you the H number, the Hitachi part number may be on that bag that you get. Wrapping. And this was just some information about ACCS. That's our facility in Marshfield. Tear down, test stand, reassembly, oil analysis. This is our warehouse. We usually try to keep at least a year's worth of inventory on hand, especially dealing with when we were just with Hitachi. We always kept at least a year's worth of product on hand in case there was every interruption in international trade or something. You know, something happened. They had an earthquake in Japan. Well, I'm not shut down. I can't get any more product. My business is just dead. Well, I can keep going for at least a year with new product for what we keep on hand.
I got a question.
Yeah.
So when we do oil samples or the oil test, should we be using the oil test kit that you guys provide here on these Hitachi screws, or are the ones that we use, if we do oil samples on other compressors, we just use, what's that, Rocky Research or?
Yeah, you can use any of them.
Okay, cool.
And you can use ours on any other compressor too. It doesn't have to be just Hitachi. You can
Okay.
use it on a train compressor or a Hanbell or whatever.
Okay.
We just offer oil analysis, but yeah,
Okay.
several people offer
Anything
it.
special with that?
No, nothing special. Then I'd put a copy of a teardown report. Just blasts it pretty quick. Photograph it as it's being torn down, or not as, well, as it was received. You know, one comes in. I show it how it came off the truck, picture of the nameplate. Any damage to the terminal plate. Pop up the terminal plate, see how the connections are underneath, if they're tight, if they're messed up or not. Then you can kind of walk through this. That's when it has some pretty bad copper plating, like you can see on that piston rod there. Where the contact was, contacting the bore housing left and right, female and male, the gap for the screws. That's when they had contact on the back where it was hitting the casing. And you get a letter. This is the oil analysis letter. A copy of the oil analysis letter you get a letter as well as a form like this. This is how many different elements it breaks down to when you do a sample. This is just a sample report. Anything bolted would be abnormal, and in the letter it'll tell you why it's bolted and what we recommend for you to do. These are some guidelines for your oil analysis, just for some high spots for like the iron, zinc, copper, moisture, acid. What is a go, no go on those readings? This is just a letter at the end of the teardown report, and the teardown report always gets oil analysis done on every one of those as well. That's why it's in here. Then a letter kind of explaining on this compressor why we think it failed, what we need to do to look at to follow up on your system. That's about it. Cool. Any other questions? You guys got any questions for what we've gone over? Anything didn't quite make sense?